Let us journey back to the very beginning of everything. Before galaxies, before stars, before even light itself, there was an unfathomable stillness, a void waiting for a spark. In this nothingness, all the energy and matter that would one day become the cosmos lay condensed, squeezed into a point smaller than a single grain of sand. It is almost impossible to imagine an entire universe, all that is or ever will be, packed into an infinitesimal seed of creation. And then, in a moment beyond time, that seed burst. In that instant, the universe was born in a blaze of light and energy. Space itself expanded faster than a lightning flash, swelling from microscopic to cosmic proportions before anything could even comprehend it. Cosmologists theorize that in that first split second, an episode called inflation caused space to swell at mind-boggling speed, far faster than light itself, smoothing and enlarging the young universe in an instant. What began as a single, tiny point blossomed into an immense, glowing cloud of pure energy, as if the cosmos itself were a gigantic newborn star. This was the Big Bang. Not so much an explosion in space, but an expansion of space, carrying matter and light in every direction. In those first fleeting moments, the cosmos was incredibly hot and dense, a brilliant, seething fireball of particles dancing furiously. As this newborn universe expanded, it began to cool, ever so slightly, moment by moment. The blinding white-hot glow softened as temperatures fell from unimaginable heights. Within the first second, the basic forces of nature, gravity, electromagnetism, and the strong and weak forces that govern atoms, separated into their own identities. An ocean of tiny particles flooded the young cosmos. Protons and neutrons, electrons and neutrinos, all streaking through space. For a brief instant, matter and its shadow twin, antimatter, existed in nearly equal measure. When they met, they annihilated each other in bursts of pure energy. Had they been perfectly equal, nothing but light would have remained. But by a mysterious and fortunate tiny imbalance, a bit more matter remained than antimatter. Physicists estimate that out of roughly 1 billion matter-antimatter pairs, only one particle of matter survived this annihilation, and all the galaxies and stars would later coalesce from that tiny residue. That small surplus of matter, perhaps only one particle in 1 billion, was enough to avoid total annihilation. It would become everything we know, every star, every planet, every living being. It is astonishing to consider how close the universe came to being empty. If not for that infinitesimal asymmetry, there would be no matter, no galaxies, no us. The fact that something, rather than nothing, filled the universe was decided in those first fiery moments. Time flowed on. By the first few minutes of existence, the universe had grown vast and cool enough for some of those protons and neutrons to come together. They fused, forming the first atomic nuclei. Most were simple hydrogen, the lightest element, along with some helium and a trace of lithium. In these first minutes, the basic recipe of the cosmos was set, a universe filled mostly with hydrogen gas, with a dash of helium, roughly 3/4 hydrogen and 1/4 helium by mass. Heavier elements, like carbon, oxygen, or iron, did not exist yet. their time had not come. For now, the young cosmos was remarkably simple, elegant in its newborn state, a vast expanding cloud of primal gas and radiant energy. Around 380,000 years after the beginning, a blink of an eye in cosmic time, the universe had cooled enough for electrons to slow down and gently join with nuclei. For the first time, stable atoms could form. An electron spiraled into orbit around a proton, and a hydrogen atom was born. Countless such unions occurred across the cosmos, turning the seething plasma into a calmer sea of neutral gas. And as this happened, something subtle and wonderful took place. The blinding fog of earlier times lifted. Light, which had been trapped, bouncing endlessly among particles, was now free to travel through space. The universe unveiled its first light, the gentle afterglow of its fiery birth, and became transparent. If one could have been there in that moment, one would see a soft, warm glow permeating space, like the diffuse embers after a great fire has died down. There were not yet any stars, but the entire sky glowed faintly with this primal light. Today, billions of years later, that ancient radiance has cooled and stretched into the faint microwave whisper we detect as the cosmic background radiation, a remnant glow from the infant universe still echoing across the sky. In a way, the universe itself remembers its infancy. Now we can tune in to this faint afterglow with radio antennas and satellites, detecting the whisper of those first photons that have been travelling for nearly 14 billion years. Yet, with the primordial glow now faded and dispersed, a grand paradox emerged. The cosmos went dark. With no new stars yet born to replace that fading brilliance, the universe entered a deep cosmic night. The newborn atoms, mostly hydrogen, drifted through the expanding void, gathering slowly into ever larger clumps under the pull of gravity. For roughly 100 million years, not a single star shone. No new light illuminated the darkness. It was a darkness deeper and longer than any night we can imagine. If one could drift through that young universe then, all would be silent and black, a cold expanse of diffuse gas and drifting atoms without form or light. The cosmos was in a dreamless slumber, awaiting its first sunrise. In this vast night, the only illumination was the fading memory of that first afterglow. The stage was set. The ingredients of creation were scattered far and wide, but the lights of the cosmic drama had yet to be kindled. In the silence of this early universe, gravity quietly went to work as a patient sculptor. Tiny imperfections in the otherwise uniform sea of gas, slightly denser patches here and there, had just enough gravitational pull to begin drawing in more matter around them. Over countless millions of years, those subtle concentrations of gas grew denser and denser. The great cosmic expansion slowed their growth, but could not halt the inexorable gathering. Filaments of gas began to weave together under gravity's guidance, forming an immense cosmic web, a network of matter like the delicate veins of a leaf or the threads of a spider's web, stretching across the darkness. At the densest knots of this web, the seeds of galaxies were planted, the future centres where countless stars would congregate, though it would be ages yet before true galaxies took shape. For now, something smaller but immensely significant was about to happen in those dark, dense pockets of gas. Within these contracting clouds of hydrogen and helium, pressure and temperature steadily rose. One by one, these dense clumps grew hotter as gravity squeezed them tighter. At first, a collapsing cloud might glow dimly red from the heat of compression, then brighter as it shrank further, its core heating to tens of millions of degrees. Imagine an enormous, invisible hand gently compressing a great cloud of gas until, at its center, it becomes hot and dense enough to ignite a new kind of fire. Deep in the hearts of these collapsing clouds, the first whispers of starlight were preparing to break the darkness. These hot, dense knots, protostars we could call them, kept being fed by infalling gas, growing more massive and hotter with each passing epoch. Gravity pulled relentlessly, until finally, the conditions were right for a dramatic transformation. The pressure and heat ignited something truly new. Nuclear fusion flared in the core of one of these protostars, and a star was born. After ages of darkness, at last came a moment of cosmic dawn. The first star's light pierced the darkness like a lone candle in an endless night. For the first time in all of cosmic history, there was a true star shining. And it wasn't alone for long. All across the universe, other clumps of gas reached their own tipping points. One by one they ignited, and countless brilliant lights winked on against the black backdrop of space. The long dark ages were ending, not with one sudden burst of radiance, but with countless little sparks spreading throughout space. Bit by bit, these bubbles of light expanded and merged. Eventually, the glow of many young stars spread through the void, banishing the darkness in their vicinity. The great cosmic night was ending. The first stars, the very first generation of stars to ever exist, blazed into existence, and with them, light returned to the cosmos in earnest. The cosmic dawn had broken. These first stars were unlike any that would come after. Born in a pristine cosmos, made only of hydrogen and helium, they grew to colossal sizes. Many were dozens, or even hundreds of times more massive than the star that now warms our Earth. With such mass, they burned their fuel at a ferocious rate, shining a brilliant blue-white and pouring out prodigious light and heat. Their surfaces blazed at tens of thousands of degrees, and their luminosity was millions of times that of our Sun. In their searing brilliance, they chased away the surrounding darkness. The powerful starlight of these primordial suns flooded space, turning the nearby cosmic gas into a faint, ghostly glow. Wherever these first stars kindled, they heated and illuminated the gas around them, carving out bubbles of light in the great night of the cosmos, like little havens of radiance in a vast dark sea. Their intense ultraviolet radiance even stripped electrons from the atoms around them, turning the surrounding gas back into glowing plasma. In this way, each new star created a sphere of light, a pocket where night was temporarily pushed back. For the universe, this was a transformative dawn. What had been a cold, quiet expanse of diffuse gas became dotted with the first points of light. Imagine drifting through that darkness and suddenly seeing, far in the distance, a cluster of newborn stars shimmering like an oasis. Each new star that flickered to life was a beacon illuminating its corner of the universe. The cosmic night was no longer complete. A multitude of little dawns spread throughout the cosmos. These early stars lived fast and died young. After only a few million years, brief moments on the cosmic clock, the first of them began to exhaust their fuel. In their hearts, for the first time in cosmic history, something extraordinary had occurred. They had forged new elements. Through the intense alchemy in their cores, these stars had taken simple hydrogen and helium and fused them into heavier substances: carbon and oxygen, neon, silicon, and more. It was an alchemy far beyond any human imagination, a natural magic only stars can perform. But such massive stars could not sustain themselves for long. At the end of their short lives, many could no longer hold back the crushing pull of gravity. In a final act of creation, they collapsed and then exploded as supernovae, titanic explosions that outshone entire galaxies for a time. For a brief moment, one of these explosions could shine brighter than a whole galaxy of billions of stars. In that ferocious blast, the star ripped itself apart. If an observer could have witnessed it from afar, they'd have seen a blinding flash in the heavens, slowly fading into an expanding nebula of stellar remnants. In those moments, the universe experienced its first stellar deaths, cosmic fireworks heralding the end of those first stars. In their violent destruction was the promise of new creation. When those first stars died, they did not die in vain. In their violent destruction, they sowed the seeds of new things. Their explosive deaths scattered the heavy elements they had forged out into space, mixing them with the primordial hydrogen and helium gas. In effect, those first brilliant giants seeded the cosmos with the very first dust of creation, tiny grains of carbon and flecks of iron and other new atoms that had never existed before. None of those first-generation suns shines in the present universe. They burned out eons ago, known to us now only by the enrichment they left behind in the stars and planets that followed. The next generations of stars would be born into a cosmos that was no longer merely hydrogen and helium, but now seasoned with this stardust. With heavy elements providing better cooling, gas could fragment into many more smaller stars, giving rise to numerous sun-like stars with longer lifespans in later eras. With each supernova, the darkness was illuminated not only by a flash of light, but by new possibilities. Because among those scattered elements were the ingredients needed one day to build planets and perhaps life. In the cosmos, even destruction became an act of creation. The universe was no longer a simple place. It now carried within it the seeds of things far more complex to come. The cosmic night had been broken. Never again would the universe be truly as dark as it was in those first ages, for the fires of stars would keep it punctuated with light across space and time. As more and more stars ignited and died, their light began to spread wider and deeper into space. The stars themselves were not destined to remain solitary. By their mutual gravity, clusters of stars drew together. Instead of lone suns isolated in the void, groups of hundreds or thousands of stars bound themselves into the first primitive galaxies. These nascent galaxies were small and chaotic compared to the majestic galaxies that would form later, but they marked the beginning of a new level of structure in the universe. We can imagine them as the first islands emerging in a dark cosmic sea, gatherings of light holding one another close amid an ocean of darkness. Gradually, these islands of stars grew in size and number. Some merged with their neighbours, combining to form larger assemblies of stars. Over hundreds of millions of years, the universe, once an almost uniform expanse of gas, transformed into a rich tapestry of lights. Points of brilliance, the early galaxies, clustered along the filaments of the cosmic web, connected by tenuous bridges of starlight and separated by enormous gulfs of nearly empty space. What was once dark and simple had become patterned and complex. A glittering cosmic web with bright nodes of galaxies and vast black voids between them, stretching across unimaginable distances. In places, dozens or even hundreds of young galaxies gathered into clusters. Great city-like congregations of stars bound by gravity. These clusters, in turn, formed vast superclusters, further weaving the architecture of the cosmos on scales almost beyond comprehension. Through this epoch, the cosmos grew ever more beautiful and intricate. The earliest galaxies were faint and ragged, glimmering with the fires of their young stars. In time, gravity continued its patient work. More gas fell into these growing protogalaxies. More stars were born within them, and the galaxies swelled in size and brightness. Where once there had been only darkness, now there were countless points of light. The cosmos was ablaze in many places, a grand network of starry realms shining in all directions. Yet in this grand blossoming, there was also violence and change. Galaxies gravitated toward one another, sometimes colliding and merging in slow-motion dances that lasted billions of years. When two galaxies met, their stars would largely pass by one another, like swarms of bees intermingling, rarely crashing directly because of the vast spaces between them. But the gravitational turmoil could warp the galaxies' shapes and throw stars into new orbits. As the galaxies interacted, great streamers of stars and gas, tidal tails, were drawn out, arcing into space like celestial bridges between the merging galaxies. Enormous clouds of gas within colliding galaxies slammed together, triggering brilliant fireworks of creation as new stars burst into life. The universe was not a static backdrop. It was alive with the drama of formation and transformation on the largest scales. In time, distinct galactic forms emerged. Spirals swirled like cosmic whirlpools or hurricanes, with curving arms dotted by bright newborn stars and glowing nebulae. Elliptical galaxies took shape as immense, spheroidal swarms of stars, glowing softly with the combined light of billions of older, reddish suns. There were irregular galaxies too, fractured and misshapen remnants of cosmic collisions. Each galaxy became an island in the cosmic ocean, a city of stars shining in the void. And among these myriad island universes was one particular galaxy, a spiral with graceful curving arms and a bright core, a galaxy we now call the Milky Way. Even the Milky Way was assembled gradually, built from the merging of smaller protogalaxies and star clusters over billions of years. On a clear night on Earth, that galaxy appears to us as a hazy band of light across the sky. The Milky Way, which early civilizations mythologized as a river of milk or a path of souls. Now we know it for what it truly is, the combined glow of billions of distant stars in our galactic home, arched overhead like a faint silver river. It was in such a galaxy that an even more intimate story would eventually unfold. But at this juncture of cosmic time, we marvel at the grander picture. The rise of galaxies, the architects of the universe's newfound order. In the grand design of the cosmos, galaxies had become the fundamental communities of stars, vast ecosystems that would foster the next stages of cosmic evolution. Within them, generations of stars would live and die, and, in at least one galaxy, on a small planet orbiting a modest star, life would one day emerge. Within each of those galaxies, inside the billions of stars now speckling the cosmos, another kind of transformation was continuously occurring. It was quiet and hidden, taking place in the cores of stars, but its consequences would be profound. Through this process, the universe was beginning to manufacture the very stuff of planets and of life itself, elements forged in stellar furnaces. Let us drift closer now, leaving the expansive vista of countless galaxies behind, and peer inside one bright star among the many. In the core of a star, the temperature soars to tens of millions of degrees, and the pressure is beyond comprehension. At such extremes, atoms collide violently and fuse together. Hydrogen nuclei, the simplest and most abundant, are pressed together and merge to form helium. In that act of fusion, a tiny fraction of mass is transformed into energy, and the star shines. This is the secret of starlight, a continuous atomic alchemy releasing light and warmth. As a star ages and uses up its hydrogen fuel, if it is massive enough, it begins to fuse helium into heavier elements, carbon and oxygen, then neon and silicon, building more complex atoms step by step. Deep within a massive star, onion-like layers of different elements form, each layer the ash of the previous burning fuel. In the innermost core, if the star is truly colossal, an element called iron eventually accumulates, the end of the line for the star's fusion fire. Iron cannot be fused to release energy. When a star's core fills up with iron, it is as if the star's heart has turned to stone. The outward pressure that held the star up suddenly falters, and then gravity wins, catastrophically. In one of nature's most awe-inspiring events, the star's core collapses in an instant, and the star rips itself apart as a supernova. For a brief moment, it shines brighter than an entire galaxy. In that ferocious explosion, the extreme conditions forge every kind of heavy element that the star hadn't made during its life. Gold and silver, iodine and uranium, and all the rest, and hurl them into space. A star that once peacefully shone now becomes a brilliant cloud of expanding debris, rich with newly forged elements mixing into the galaxy around it. Sometimes the crushed core left behind remains as an exotic object, a neutron star, essentially an atomic nucleus the size of a city, or if the star was massive enough, it collapses further into a black hole from which no light escapes. Even stars not massive enough to explode contribute to this cosmic alchemy. A star like our Sun, moderate in mass, will live a long, steady life, gently fusing hydrogen into helium for billions of years. In its final stages, it will swell into a red giant and then gracefully cast off its outer layers into space, forming a beautiful glowing planetary nebula. A gossamer shell of enriched gas expanding outward, while its core shrinks to a hot, dense ember called a white dwarf. Astronomers today witness such ghostly visions in our own galaxy, like the Ring Nebula and the Helix Nebula, cosmic smoke rings left behind by dying sun-like stars. In those cast-off layers are carbon, nitrogen, and other elements that the star created during its lifetime. Thus, even the quiet deaths of smaller stars seed their surroundings with newly made elements. The vast interstellar spaces within each galaxy become enriched by the contributions of dying stars, both violent and gentle. Generation by generation, stars continue this cycle of birth, life, and death. Each new generation is born from gas that has been enriched by the stars before it. With each cycle, a galaxy grows richer in heavy elements. Think of it as a cosmic garden. The stars are like blossoms that bloom and then wither, their remains fertilizing the soil of space for new growth. Over billions of years, this stellar cycle changed the content of the universe. From the pristine simplicity of hydrogen and helium The cosmos gradually accumulated all the diverse elements of the periodic table: the copper in a coin, the calcium in a seashell, the oxygen we breathe. All of it was brewed in stars over the eons and spread through space by stellar winds and explosions. Indeed, the universe was slowly writing the recipe for life, manufacturing carbon for future cells, oxygen for future breaths, calcium for future bones, long before life itself existed. And indeed, we ourselves are made of this stardust. The iron in your blood, the calcium in your bones, the carbon in every cell of your body, all were forged in ancient stellar furnaces and scattered across the galaxy, only to become part of us much later. Look around and within yourself. Nearly every atom in your body was once inside a star. The iron in your blood was born in a star's core and liberated by a supernova. The calcium in your teeth was cooked up in some long ago dying star. The very substance of our bodies, of our world, was fashioned in the hearts of distant suns. We are literally star-made. Among the elements forged in those stars were those especially suited to form solid matter, the building blocks of future planets. In the great clouds of gas that swirled through galaxies, tiny dust grains began to condense and form, made of carbon and silicon, iron and ice, and other ingredients. Unlike the free-floating gas, these dust motes could stick together, clumping slowly into larger and larger pieces. Within this cosmic dust, a new potential was hiding, the potential to form worlds. And so we arrive at the next stage of the cosmic story, one that carries us from the grand scale of galaxies and stars down to the more intimate realm of planets. Across the galaxies, within immense clouds of gas enriched by generations of stars, new suns were taking shape. Around those newborn suns, disks of leftover gas and dust swirled like cosmic potter's wheels, ready to form planets. Picture one such scene in a spiral arm of the young Milky Way galaxy. About 4.6 billion years ago, a massive cloud of gas and dust, enriched with the heavy elements from earlier stars, begins to contract under its own gravity. As it collapses, it flattens and spins faster, spreading out into a broad disk. In this disk, material circulates like a whirlpool around the central protostar. The inner regions grow hot and luminous, while the outer regions remain cooler and dusky, strewn with countless grains of dust, the seeds of future worlds. At the center of this disk, matter gathers into a growing ball, a protostar, that will one day ignite to become a new star, our sun. Closer to the center of the disk, where it's warmer, dust grains stick together to form pebbles, then rocks, then boulders. Over millions of years, these collide and merge, building up larger and larger bodies. Farther out in the disk, where it's cooler, not only rock, but also ice can collect, helping to form different kinds of nascent worlds. Gradually, the larger clumps of dust and rock become planetesimals, the seeds of planets. They dance around the young sun-to-be, sometimes gently coming together, sometimes violently crashing apart. Each collision can be both destructive and creative, shattering bodies into fragments, or welding smaller pieces into a larger whole. Many smaller proto-worlds are flung into the nascent sun, or ejected to the cold outskirts, casualties of gravitational tussles in the crowded disk. As time goes on, these baby planets clear their orbital paths, gathering up the remaining debris in their neighborhood. The disk that was once a chaotic mix of gas and dust begins to organize into a newborn solar system. Meanwhile, at the very center of it all, pressure and heat continue to rise until, at last, nuclear fusion ignites in the protostar's core. Our sun is born, blazing with a steady golden light. The intense energy and stellar wind from the young sun blow away much of the remaining gas in the disk, especially from the inner regions, leaving behind primarily the solid worlds and smaller rocky remnants. Closer to the star, 4 small rocky planets have taken shape, forged from metal and rock: Mercury, Venus, Earth, and Mars. Farther out, where ices and gas were plentiful, great giants have formed: Jupiter and Saturn, gathering massive envelopes of hydrogen and helium, and Uranus and Neptune, with their frigid gas layers and icy cores. Countless smaller leftovers remain as well. Swarms of asteroids, icy comets, and dwarf planets on the fringe. In a few 100 million years, the entire scene settles into a kind of balance. A solar system in place, with planets large and small circling a shining new sun. This stable architecture would endure for eons, providing a stage where new wonders could develop. On one of those newborn planets, the third one out from this fresh star, conditions turn out to be something special. This planet, Earth, is a world of rock and metal, initially shaped by fierce collisions and then gradually smoothed by time. In fact, one final giant impact, early in Earth's history, tore away a portion of its mass. From that debris, our moon coalesced, and thereafter, Earth would have a permanent companion, illuminating its night sky. The moon's gravity pulls on Earth's oceans, creating tides, and its steady presence helps keep Earth's axis tilt stable, fostering relatively gentle seasons over long ages. Early on, Earth is a blazing sphere of molten rock, glowing red-hot from the violence of its birth and incessant bombardment. But as time passes, it begins to cool. A solid crust forms over the liquid fire below. Volcanoes dot the young landscape, breathing out gases that form a nascent atmosphere. This primordial air is thick with carbon dioxide, nitrogen, and water vapor, but virtually no oxygen, a sky utterly alien to the one we know now. Comets and asteroids rain down, delivering water and other rich chemicals to the surface. Eventually clouds gather and rains fall, and oceans pool across the cooling crust. Thunderstorms sweep across those young seas, lightning flashing in the turbulent skies as the planet slowly calms. By a few 100 million years after its formation, the Earth has transformed from a hellish ball of fire into a planet with blue seas and grey continents under a pale sky, a setting ripe with potential. For many millions of years, Earth would remain a world of lifeless land and sea, while complex chemicals mingled and reacted in its oceans. Yet Earth is just one example of what this grand process can produce. All across the galaxy, and indeed across the universe, countless other stars have their own families of planets. Some of those worlds will be barren rocks scorched by their suns, or giant gas planets with no solid surface, too hostile for life as we know it. Others might be water-rich ocean worlds, planets entirely covered by global seas. Some could have gentle climates, where clouds drift over alien mountains and plains beneath skies tinged with unfamiliar colours. Perhaps there are planets with 2 suns in their sky, casting twin shadows on the ground. Another world might be adorned with magnificent rings and a crowd of moons. Some planets are locked in eternal frost, ice balls shrouded in darkness, while others skate perilously close to their stars, their surfaces molten under a brutal stellar glare. There are even rogue planets knocked out of their systems entirely, wandering the galaxy alone in perpetual night, unbound to any sun. The cosmos, through the forging of heavy elements in stars and the gathering of dust in planetary disks, has given rise to an unimaginable variety of worlds. Each one is a new canvas for further cosmic evolution, a place where chemistry can become complex, and where something truly remarkable might one day take root. Consider, for instance, a single atom now within your body, an iron atom in your blood. Its journey began long before the Earth existed. Perhaps it was forged in the core of a massive star in our galaxy's early days, created when that star fused lighter elements into iron. When the star's life ended in a spectacular supernova, that iron atom was hurled into space amid the stellar debris. For millions of years, it drifted through the galaxy as part of a great cloud of gas and dust. When that cloud later collapsed to form our Sun and its planets, the iron atom found its way into the young Earth. It sank into the new planet's interior and became part of the iron-rich rocks. Through the slow cycles of geology, some of that iron emerged again at Earth's surface. Eons later, it might have been taken up by a plant, incorporating that iron into living tissue. And long after that, in our own time, you might eat the fruit of that plant, bringing that iron atom into your body. Now it courses through your veins, helping your blood carry oxygen to your cells. In this way, a single atom connects you to a star that died long ago. Multiply that story by trillions, for every atom in your body has a similar tale. We are truly intertwined with the cosmos. From the first spark of creation nearly 14 billion years ago, to the formation of these new worlds, we have witnessed the universe's journey from simplicity to complexity. What began as a single burst of primordial energy has led to a cosmos filled with galaxies of stars and a multitude of planets, including the serene blue gem of Earth, all drifting through the darkness. The stage is set. On at least one world, the gentle lap of waves on an early ocean foreshadows a new phenomenon about to emerge. The universe, once only a vast expanse of matter and energy, is on the cusp of something profoundly new, the awakening of life and consciousness. It is a story of creation on the grandest scale, of transformation, of cycles of death and rebirth. In contemplating this immense history, our own existence occupies but a fleeting moment. If we were to compress the universe's 14 billion year timeline into a single calendar year, a human lifetime would last only a fraction of a second, and all of recorded human history would flash by in the final seconds of December 31st. We arrive at the tail end of this cosmic epic, awed spectators to a story that began long before we existed, and it is only the beginning. As our journey continues, we will see how these newborn worlds, built of stardust, can themselves give rise to their own sparks of creation. The origins of living beings who can gaze back at the sky in wonder. For now, we drift in the cosmic ocean, carrying with us the humble knowledge that every atom in our bodies was forged in ancient stars, and every breath we breathe is part of this vast history. The universe has built the foundation, The next chapters will reveal what becomes of these newfound worlds under the light of their stars. Night falls, and the sky darkens to reveal a splendor of stars. Above us, a million distant suns prick the darkness, quiet and mysterious. The Milky Way arcs overhead as a pale, misty river of light, a reminder that our own galaxy is an island of countless stars in a vast cosmic sea. Under this dome of heaven, on a silent night far from city lights, you can feel the infinity overhead, pressing down in its silence. Generations before us have looked up in wonder at this very sight, asking questions about their place in the universe. Now, in our age of science and exploration, we are beginning to uncover answers, though these answers often raise even deeper questions. Our journey through the cosmos has already carried us across countless wonders. We have drifted past luminous nebulae where stars are born, sailed among the majestic spiral arms of galaxies, and gazed at distant stars that glitter like lanterns in a deep, velvet expanse. Now, as we venture further into the silent, star-washed void, a gentle cosmic quiet surrounds us. The Milky Way stretches overhead like a faint silver river in the darkness. In this stillness, with starlight painting the sky, we pause to reflect on our place in the vast tapestry of the universe. Far from the noise of our world, under a moonless sky filled with the glow of distant suns, one can lie back against the cool grass and feel at once small and infinite. Above, millions of stars shimmer, each one a distant sun in its own right, with no sound but the beating of our hearts and the whisper of our breath. We sense that we are afloat in a boundless cosmic ocean. In that quiet moment, an awareness begins to stir. We are not just observers of the universe, but an intimate part of it. The atoms in our bodies were forged in ancient stars long ago, and now those atoms sing within us as we contemplate the sky. We, who gaze up at the galaxies, are made of the very same star stuff that glows above. Under the arch of the night, a feeling of connection takes hold. Each star overhead could be the center of a distant solar system, encircled by worlds unknown. Perhaps, on some far-off planet, orbiting one of those stars, there is an ocean reflecting alien constellations, or a stretch of alien desert under twin suns. And perhaps beneath that unfamiliar sky, a being not so different from us looks up in wonder. They might have two moons rising together, or a sky tinted in colours we have never seen. Yet, in their heart might bloom the same question that arises in ours. Am I alone, or is there someone out there looking up at the same stars? In that thought, the cosmos feels more intimate, as if all who watch the stars are linked by a subtle bond. We do not yet know whether any distant observers truly exist. The universe has kept its secrets well. So far, our radio messages into the void have met only silence. If, in the vastness of space, we are truly the only beings who have awakened to self-awareness, then our role is a profound one: to be the universe's lone voice and consciousness, a way for the cosmos to know itself. If, on the other hand, the universe is teeming with life, then one day our awareness may meet another's. Across the light years, a greeting might be returned, and the universe will know itself in a new, richer way, through many eyes and minds. Either possibility fills us with wonder and humility. So we continue to listen and to send out our own greetings in the hope that we are not alone. And even if that answer never comes, we find companionship in the stars themselves. The cosmos is full of marvels that inspire us and keep us company in the long night. In the meantime, beneath the quiet sky, we find unity in knowing that we and the universe are inseparable. Breathe in the night air and consider that the air filling your lungs right now carries atoms exhaled by distant forests and ancient seas. Those atoms have traveled through time and space, through countless life forms and landscapes, before becoming part of you. And the gentle starlight that falls upon your face set out from its star years, or even millennia ago, crossing the cosmic ocean to touch you here in this moment. When that ancient light mingles with your eyes, the boundary between out there and in here fades. You become the meeting point of the earth and the stars, of past and present, of the vast universe and the thoughts within you. To look up at the stars is also to look back in time. The faint glow you see from a distant sun might have left on its journey toward Earth before you were even born. Some starlight arriving tonight began its trip thousands of years ago, long before human civilization as we know it. We never behold the stars as they are now, but rather as they were long ago. In this way, the night sky is a time machine, each star a messenger from a distant epoch. It's possible that a star you admire tonight has already exhausted its life and faded or exploded, yet we won't learn of its fate for ages, because its final light is still on its way. Thus, when we gaze into the night, we are witnessing history, a cosmic memory projected across the heavens. The sky above is not just a tapestry of space, but of time as well, knitting together past and present in each glittering point of light. In this profound stillness, we begin to sense the subtle threads that connect us to the cosmos. We often imagine the universe as something distant and separate, a faraway spectacle we watch from our tiny corner. Yet the truth is more magical. We are woven into the fabric of the universe, just as it is woven into us. Every heartbeat, every breath, every flicker of thought is part of a much larger story. As we float here, cradled by the night, we realize that our voyage of discovery is not just about traveling outward, but also inward, into understanding our own connection with all that exists. For generations, we could only dream about planets circling other suns. We looked up at the myriad stars and wondered if some of them might harbor worlds like our own, a place with warm sunlight, blue skies, perhaps life gazing back. Yet for most of human history, these were only questions without answers. That began to change in the late 20th century. Astronomers finally detected the subtle signs of a planet beyond our solar system. It started with a tiny wobble in a distant star's movements, a slight rhythmic tug that betrayed the presence of something unseen. In 1995, the existence of a planet orbiting a sun-like star was confirmed for the first time. It was a giant world, scorching hot and skimming precariously close to its star. Nothing like the serene Earth we hoped to find. But it was a world nonetheless. Proof at last that the darkness beyond our solar system was not empty, but filled with other suns and other worlds. That discovery opened a new chapter in our cosmic story, a true exoplanet revolution. At first, finding these distant worlds was painstaking work. Each new planet was a small miracle of detection, discovered by looking for subtle clues. A star ever so slightly swaying to the tug of an orbiting companion, or its light dimming for a few hours as a planet crossed in front of it. But as our methods improved, the discoveries quickened. We launched dedicated planet-hunting observatories, like NASA's Kepler Space Telescope, that stared at hundreds of thousands of stars for years, watching for the tiniest flickers of shadow from transiting planets. Before long, the evidence of planets began to pour in by the dozens, then hundreds. What had once been invisible became unmistakable. Planets are abundant. In the decades since, we have found not just one other world, but thousands. The number of known exoplanets has exploded, revealing an astonishing menagerie of alien worlds. It turns out that planets are astonishingly common. Almost every star we look at seems to have a family of planets, large or small. Indeed, there may be more planets in our galaxy than there are stars. Planetary systems appear to be the rule, not the exception. We have found enormous gas giants larger than Jupiter that orbit so close to their stars that their atmospheres sizzle and stream away like comets. We have found planets locked in orbits around two suns, rising and setting in twin dawns and dusks. We have found worlds enshrouded in eternal darkness, tidally bound to their stars, so that one hemisphere bakes under perpetual daylight, while the other freezes in endless night. And remarkably, not all planets even have a star to call home. Astronomers have identified a few planetary nomads adrift in space, orphaned worlds unbound by any orbit. These rogue planets wander the galaxy in perpetual night, likely flung away from their birth stars long ago. Imagine a lonely planet floating through the dark, its surface lit only by faint starlight from distant suns, or perhaps the ghostly glow of its own residual heat. Such a world would know no sunrise, only an endless cosmic midnight. Yet it is still a planet, a piece of the universe's grand collection of worlds, reminding us that in space, reality can outpace even the strangest fiction. Some of these newfound planets are strange, beyond our early imaginings. There are hot Jupiters, massive gas worlds that hug their stars so tightly that a year on those planets might last only a few days. On their sunward sides, clouds of metallic minerals could rain drops of molten iron. There are planets where the skies might be forever red, illuminated by dim red dwarf stars. On one such world, perhaps the landscape is bathed in a perpetual sunset glow. There are planets several times the mass of Earth, so-called super-Earths, that may be rocky and might boast thick atmospheres or global oceans. And among these exotic places, we have even found a few that, from all we can tell, might be rather familiar. Rocky planets of similar size to Earth, orbiting at just the right distance from their stars for liquid water to exist. Even the nearest star beyond our Sun, Proxima Centauri, a faint red sun just over 4 light-years away, has at least one planet in its orbit. This little world, only slightly more massive than Earth, lies in a zone where temperatures could allow liquid water to pool on its surface. Our cosmic next-door neighbour, it seems, may hold its own version of an Earth-like haven. If there are lakes or oceans on that world, they circle a star so close in astronomical terms that one day, far in the future, we might dream of sending a probe to visit. These potentially temperate worlds excite our imagination most of all. Around a small, faint star not too far away, we discovered a remarkable system of 7 Earth-sized planets, each circling their dim sun in a tight, rapid dance. Several of those planets lie in the star's Goldilocks zone, where conditions could be just right for liquid water, that essential ingredient for life as we know it. If you could stand on one of those worlds, the star in your sky would be a reddish orb, dimmer than our sun, but much larger in appearance, and you might see the sister planets as bright lights, even disks, crossing the heavens, near enough to touch, it would seem. We have also found planets only slightly bigger than Earth that orbit stars similar to our sun at comfortable distances, their presence detected by the faint dimming of starlight as they pass in front of their suns. When these planets transit their stars, it's as if a small voice speaks from across the galaxy, telling us, "I am here." At times, we have even managed to glimpse these distant worlds directly. Using ingenious techniques, astronomers have taken photographs of a few young, massive exoplanets, capturing them as faint pinpricks of light near blinding stellar beacons. In those images, each tiny dot is a world unto itself, a place with skies and perhaps clouds, with unknown landscapes, and maybe even moons. Seeing such a speck of light, knowing it is a planet hundreds of trillions of miles away, stirs the soul. It is a humbling reminder of our reach. From a tiny observatory on Earth, our curiosity can extend a hand across the light years and briefly touch another world. We stand now in an extraordinary era of discovery. In a single generation, we went from wondering if other planets exist to knowing that the galaxy is brimming with them. More than 5,000 exoplanets have been confirmed, and the tally grows each month. They range from hellish spheres of fire to frigid balls of ice, from bloated giants that skim the edge of their stars to small, solid orbs that might be cousins of our own Earth. And with each new discovery, we learn more about how unique, or how common, our own solar system might be. In fact, one unexpected lesson has been that our cosmic neighborhood may be something of an outlier. Many planetary systems don't look like ours at all. One example is the prevalence of planets intermediate in size between Earth and Neptune, often called super-Earths or mini-Neptunes. These worlds, larger than our Earth but smaller than the ice giants of our system, appear to be very common elsewhere, and yet our Sun has none. They might be rocky planets with thick atmospheres, or water-rich ocean worlds, or something in between. Their abundance tells us that nature often builds planets in this size range, prompting us to wonder what such worlds are like and why our solar system missed out on this common bounty. We see systems with planets crammed so close that they orbit faster than Mercury, and systems with multiple suns entwined in gravitational embraces. We find planets so light and puffy that they could float in water, and others as dense as iron. Every world we find raises new questions. How do planets form in such variety? How many might host life? Is our Earth an outlier, or one of many living worlds scattered through space? We have begun to detect the chemical makeup of some exoplanet skies by analyzing the starlight that filters through their atmospheres when they transit. In the spectra of that dimmed starlight, we can discern the fingerprints of elements and molecules, the haze of clouds, perhaps, or the presence of water vapor. One day, We hope to catch the telltale signs of life in such observations, the oxygen produced by alien plants, or the faint signature of organic molecules that betray the existence of living creatures under an alien sun. Already, our most advanced telescopes are giving us a taste of what's to come. The recently launched James Webb Space Telescope, with its keen infrared eyes, has begun peering into the atmospheres of some of these worlds. In the faint starlight shining through a distant planet's clouds, Webb has detected the signature of water vapor and even hints of swirling clouds and hazes on giant planets many light years away. Each discovery is a proof of concept that we can, in a sense, touch these far-off worlds with our science, sniff their air from across the void, and search it for the ingredients of life. Intriguingly, the hunt has expanded beyond just planets. Astronomers are searching for exomoons, moons orbiting distant planets, and there are tantalizing hints that the first such moon may have been observed. In some young systems, we also detect belts of dust and comets, the building blocks and leftovers of planet formation. These observations suggest that distant planetary systems can be just as rich and intricate as our own, with rings, moons, asteroids, and comets weaving their subplots into the grand narrative of their sun and planets. For now, those signs of life elude us. But the search is only just beginning. With each improvement in our telescopes and instruments, our eyes grow a little sharper. We have space observatories drifting above Earth's atmosphere, patiently watching thousands of stars for the slightest dip in light that means a planet has passed by. We have radio antennas listening for whispers from civilizations that might be broadcasting their presence. We have roving probes and dreams of starships to one day visit nearby exoplanets, though the distances are staggering. Our explorations are still in their infancy, yet already we know planets are everywhere. The implications of this knowledge are profound. Somewhere among the countless worlds in the galaxy, there may be one not so different from our own. A blue world warmed by a friendly star, with continents and oceans, with life swimming in its seas or walking on its lands, and eyes turned skyward in curiosity. Or perhaps life there takes forms we cannot imagine, thriving beneath an ice-covered alien sea, or eking out an existence in the thick clouds of a gas giant. It's even possible the cosmos teems with microbes and simple life, while intelligent life remains rare. We do not know. But just knowing that these worlds exist has changed the way we see the night sky. The stars are no longer distant, lonely lights. They are suns with their own families, part of a vast cosmic neighborhood. Picture a distant planet, if you will. One of those we have detected across the gulf of space. Imagine standing on its surface. Perhaps it has a lavender sky, and rings arching overhead like Saturn's, or red-leafed vegetation drinking in the dim light of a small star. What would the wind feel like on your skin, the pull of gravity under your feet? What strange constellations would adorn the night, and would its moon, or moons, cast a silvery glow on alien oceans? Contemplating these unknown landscapes, we cannot help but feel a kinship with any life that might dwell there. For just as we have sprung from the chemistry of our Earth, shaped by our sun's warmth, any beings there would be the children of their own world and star. In them, if they exist, the universe would have brought forth another means of understanding itself, another way for atoms to dance and dream, The thought of these distant worlds ignites our curiosity and our wanderlust. We can't yet travel to the stars, but human ingenuity is boundless. We dream of ways to bridge the light years, perhaps fleets of tiny laser-powered sails, or future starships that one day, far from now, could voyage to those nearby Earth-like planets. If and when that day comes, the first explorers to set foot on an alien shore will carry all of us with them in spirit. They might stand under a foreign sky and see our sun as just another distant star, completing a circle of discovery that began when we first looked up and wondered. For now, such journeys live in the realm of imagination and ambition. Until we find the means, we rely on our observatories and probes as our nomads, venturing in our stead across the void. With each new planetary discovery, those far-off places become a little more real to us. As we catalogue these myriad new worlds, we also come to appreciate the delicate cosmic choreography that keeps them in their orbits. Each planet circles its star, held close by the gentle tug of gravity. This force, invisible yet relentless, binds moons to planets, planets to stars, and stars together in galaxies. It is the sculptor of worlds and the architect of the heavens. The same force that pins us to the earth and guides the moon around us is at work in the distant systems we observe, drawing circles and ellipses in the darkness. And yet, gravity is more than just a tether between objects. It is a subtle conversation between matter and the very fabric of space and time. To truly understand the grand dance of planets and stars, we must follow gravity to a deeper level, into the underlying tapestry of space-time that it so beautifully weaves. Gravity is a familiar friend. We feel its pull with every step as it anchors us to the earth, and we see its work in the graceful arc of the moon as it circles our planet. Yet what is gravity, really? For centuries, it was thought to be an invisible force reaching across space, drawing objects together. Apples fell and planets moved under this mysterious influence, as Isaac Newton so elegantly described long ago. But in the early 20th century, our understanding underwent a profound shift. A new idea emerged, one that painted gravity not as a force exchanged between distant objects, but as something woven into the very stage on which the cosmic drama unfolds. Space and time, he realized, are not separate, rigid backgrounds at all. They are intertwined into a four-dimensional fabric, what physicists call space-time, that can stretch, sag, and warp. Gravity, in this new picture, is nothing other than the bending and curving of space-time itself. It's a difficult concept to grasp at first. How can space and time bend? Try to imagine space-time as a vast, invisible stretch of fabric, like a cosmic trampoline extending in all directions. Every object with mass, planets, stars, galaxies, sits on this fabric, deforming it slightly under its weight. For example, picture the sun resting on the fabric of space-time, creating a gentle dimple around it. The Earth, like a small ball rolling nearby, finds itself caught in that dimple and circles around the sun, not because the sun reaches out and pulls the Earth with an unseen hand, but because the Earth is following the curved space that the sun's mass has created. In this way, matter tells space-time how to curve, and space-time tells matter how to move. The beauty of this revelation, first articulated by Albert Einstein in his theory of general relativity, is that it explains so much of what we observe. Light from distant stars bends as it passes near massive bodies, as if searching for the straightest path along a curved road. Time itself runs at different rates, depending on how deep one sits in a gravity well. Clocks tick just a little slower on Earth's surface than they do high above in orbit, where gravity is weaker. An astronaut living on a space station, floating above much of Earth's gravitational pull, will age ever so slightly faster than her twin back on the ground. The difference is minuscule, fractions of a second over a year, but it is real, a gentle whisper of time's changeful nature under gravity's sway. Even our modern technology must heed this subtlety. The GPS satellites above Earth adjust for the slight time dilation in orbit to maintain the precision we rely on. If you were to hover near the intense gravity of a neutron star or the edge of a black hole, a few minutes spent there could correspond to years passing elsewhere. Space and time stretch and flex under the influence of mass and energy, knitting a dynamic tapestry where the presence of a massive object can be felt even by things that never touch it. We have seen the fabric of space-time reveal itself in extraordinary ways. During a total solar eclipse in 1919, astronomers photographed the positions of stars near the sun's darkened silhouette and found the starlight was indeed deflected, the stars appearing slightly out of place. This dramatic result, announced to the world, confirmed Einstein's bold prediction and captivated the public. Evidence that Newton's long-reigning theory of gravity had been superseded by a deeper understanding. In the decades since, we have found many other proofs. A long-observed oddity in Mercury's orbit, a slow drift in its closest approach to the Sun each cycle, that only the curvature of space-time could fully explain, or the way light leaving a massive star emerges slightly reddened, losing energy, due to gravity's pull, or how massive clusters of galaxies act like cosmic lenses, warping the light of far-off galaxies into smeared arcs and rings. These Einstein rings are a beautiful demonstration of gravity's lensing effect. In fact, astronomers now use massive clusters as cosmic magnifying glasses, observing distant galaxies whose light is bent and amplified by a closer cluster's gravity, allowing us to see farther into the universe than ever before. It's a testament that space-time, though invisible, has shape and structure we can detect and even utilize. Gravity, then, is not so much a force pulling on objects as it is objects following the contours of space-time. Imagine walking across a broad valley. You naturally descend into the dip and then climb up the other side. To you, it feels like being pulled downhill and then fighting against a pull uphill. Yet you are simply following the landscape's curvature. In much the same way, we live our lives, never realizing that we are always moving through the curves and slopes of space-time. We sit at the bottom of the shallow gravity well that Earth makes in space-time. And our weight is just our feeling of being held in that well. If you could remove that support, say by stepping off into open space, you would feel weightless, not because gravity vanished, but because you'd be in free fall. This is exactly the case for astronauts orbiting Earth. They are still within Earth's gravity, but they are falling around the planet in a continual state of free fall. With nothing to stop their fall, they experience no sensation of weight, effectively floating even as gravity silently guides their path. The Moon follows a curved path around the Earth for the same reason. There is no mysterious force tugging invisibly at it, only the natural motion along the indentation Earth creates in space. In space, planets and stars move along the valleys and slopes created by each other's presence. And just as the Earth's landscape can ripple with hills and valleys, the cosmic fabric can ripple too. If a massive object moves, or two massive bodies dance around each other, they send tiny tremors through space-time, like the faint ring of a faraway bell echoing across a vast lake. But we will come back to those cosmic ripples later. Through all these phenomena, we come to appreciate gravity as the master weaver of the cosmic tapestry. It sculpts the architecture of the universe, drawing matter together to form stars and galaxies, and shaping the pathways that planets and light must follow. Over billions of years, the gentle but relentless tug of gravity coaxed a nearly uniform early cosmos into the rich cosmic web of today. It is gravity that orchestrates the motions of the heavens, from the elegant dance of double stars to the majestic rotation of galaxies. Without it, the universe would be structureless and still. With it, the cosmos thrives with complexity and motion. Gravity quietly writes the grand story of creation and evolution on the largest scales, even as it governs our everyday lives here on Earth. Yet gravity also has a darker, more mysterious side. For all its gentle binding and shaping, gravity can become ferocious when concentrated. Imagine piling more and more mass into one spot, compressing a star, 10 times the sun's mass, into a sphere no larger than a city. The curvature of space-time steepens tremendously, like a well deepening without bound. At a certain point, the deformation becomes so extreme that it creates a hole in the fabric of space-time itself, a region where the curvature becomes infinite, and anything that ventures too close is lost from view. This is the phenomenon we know as a black hole, gravity's abyss, from which not even light can escape. Having followed the threads of gravity's tapestry to this extreme, we find ourselves peering over the edge of an all-consuming chasm, the entrance to one of the greatest enigmas in the universe. We stand at the brink of an abyss that defies intuition. A black hole is the ultimate endpoint of gravity's triumph, a region where the fabric of space-time has been pulled so steeply inward that nothing can climb back out, not a rocket at full throttle, not even a beam of light. It is a one-way trapdoor in the universe, a place of no return. The very term black hole evokes an image of a dark, bottomless pit, and in many ways, that image is apt. But the reality of a black hole is stranger and more fascinating than any simple hole in the ground. It is a warped region of space and time, the end result of gravity crumpling a mass into an infinitesimal point. How does such a cosmic abyss form? In the death throes of a massive star lies one answer. Stars live by the balance of forces, the outward push of heat and light from nuclear fusion at their core, and the inward pull of gravity from their own immense mass. For a star like our Sun, this balance can last billions of years. But for a star, perhaps 10 or 20 times the Sun's mass, the end comes in a spectacular collapse. When the star exhausts its nuclear fuel, it can no longer resist gravity's inward tug. The core implodes in a fraction of a second, and the outer layers erupt outward in a colossal supernova explosion. What remains of the core is crushed ever tighter by gravity. If the dying core is heavy enough, around 3 times the Sun's mass or more, no known force in nature can halt the collapse. At that moment, The core continues collapsing past any hope of stability, and a black hole is born. All the mass of that star is now concentrated in an unimaginably small volume. The gravity at this collapsed core is so intense that close by, space itself falls inward faster than the speed of light. We call the boundary around a black hole the event horizon, an invisible spherical surface that marks the point of no return. Once anything, a particle, a spaceship, a ray of light, passes through that horizon, it is as good as gone from our universe. It can no longer communicate or travel back out. To an outside observer, that infalling object appears to slow down as it nears the event horizon, its clock seeming to almost freeze, and its light growing redder and dimmer, fading away just at the edge. But from the object's own perspective, nothing extraordinary occurs at that boundary. No sudden jolt, just a continuing descent into darkness. What lies inside a black hole? In the center, according to Einstein's theory, all the mass collapses to a point of infinite density and zero volume. The singularity. It is a place where our current understanding of physics breaks down. Space and time as we know them likely cease to make sense under such extreme conditions. Some scientists suspect that quantum effects, rules of the very small, might soften these infinities, perhaps spreading the mass out or creating a new state of matter or space. But truthfully, no one knows for sure. The interior of a black hole remains one of the most tantalizing mysteries in all of science, sealed away behind the event horizon. It is the enigma at the heart of a black hole, an ultimate unknown in a shadowed realm where our equations yield infinities. While we cannot see a black hole directly, since no light comes from within, we have many ways to know they are there. Just outside the event horizon, infalling gas and dust swirl into a black hole, like water down a drain. As this matter spirals inward, it heats up and glows brilliantly, often emitting X-rays and other high-energy radiation that we can detect. Many black holes announce their presence through these powerful X-ray beacons, or through spectacular jets of particles that shoot out from the vicinity of the hole, powered by the magnetic and gravitational fury of the accretion disk. In distant galaxies, we observe quasars, staggeringly bright beacons visible across the universe. These are powered by supermassive black holes devouring matter at their centers, shining brighter than billions of stars as they feast. In a quasar, a hungry black hole turns into a cosmic lighthouse. As gas and dust pour into the black hole's grasp, they form a swirling accretion disk that can outshine the entire galaxy. Temperatures in the disk soar to millions of degrees, and intense magnetic fields channel some of the infalling matter into twin beams shooting out from above and below the black hole. These jets of plasma, moving at near the speed of light, can extend for tens of thousands of light years, blasting through interstellar space. To a distant observer, a quasar looks like a brilliant star-like point, but what they are really seeing is the glaring radiation from the accretion disk and jets of a supermassive black hole in the galaxy's heart. It is a spectacular paradox. One of the darkest objects in existence, creating one of the brightest phenomena in the universe, all due to gravity's relentless pull. There is also the evidence seen in the dance of stars. In our own Milky Way galaxy, astronomers have patiently watched stars near the galactic center orbiting an unseen object. These stars whip around at incredible speeds, following paths that betray an enormous mass concentrated in a tiny area. Calculations reveal that only a black hole, with a mass about 4 million times that of our Sun, could cause such motions. Remarkably, when one of these stars, known as S2, swung especially close to the unseen mass in 2018, its light was shifted to redder wavelengths by the intense gravity, exactly as general relativity predicted. It was a dramatic demonstration of Einstein's theory unfolding in real time, right in the heart of our galaxy. We call this central monster Sagittarius A, and though it is relatively quiet now, not actively consuming large amounts of matter, it still occasionally flares as it snacks on an asteroid or a puff of gas. It's a sobering thought that at the core of our galaxy lies a giant black hole, like a sleeping dragon at the heart of a starry island of light. And black holes can grow far larger still. In fact, evidence suggests that nearly every large galaxy harbours a supermassive black hole in its core. These hidden giants and their galaxies likely grew together over cosmic time, each shaping the other. In the centres of some galaxies, billions of light years away, lurk even more massive black holes. Some with the mass of hundreds of millions, or even billions of suns. These ancient behemoths likely formed in the early universe and grew by merging with others and swallowing matter over eons. They shaped the galaxies around them, affecting star formation and stirring the hot gas in galaxy clusters with their jets. For a long time, black holes were purely theoretical objects, predicted by equations, but doubted by many. But now we have not only inferred their presence, we have seen the silhouette of a black hole with our own eyes. In 2019, an international team of scientists linked radio telescopes around the world to create an Earth-sized observatory, the Event Horizon Telescope. They aimed it at a huge black hole in the galaxy M87, 55 million light-years away, and captured an image of the unseeable, a fuzzy, donut-shaped ring of light surrounding a dark center. That dark patch was the shadow of the black hole itself, where light is swallowed. For the first time, humanity glimpsed the abyss up close, confirming once more that these fantastical objects of theory are very real. And in 2022, the same Event Horizon Telescope unveiled the shadow of the black hole at the center of our own Milky Way, giving us a picture of the gentle glowing halo of gas around the quiet dark heart of our home galaxy. What would it be like to approach a black hole? Let us imagine for a moment that we are bold travelers, venturing toward one of these cosmic chasms. Far from it, we might hardly notice anything amiss. Its gravitational pull from a distance is no different than that of any other object of the same mass. But as we draw nearer, we would feel gravity's grip growing stronger, faster. Suppose we head toward a stellar mass black hole, one formed from a collapsed star. It might only be a few miles across. As we get close, the pull on our spacecraft's nose is noticeably stronger than on its tail. Gravity varies so sharply across even a short distance that the difference would start to stretch our craft. If we got too close, this tidal force would become lethal, pulling objects into long, thin shapes in a gruesome effect whimsically named spaghettification. Anything, or anyone, falling in feet first would feel their legs pulled far more strongly than their head, stretching the body out, while also squeezing it from the sides. It is safe to say we would not survive crossing the horizon of a small black hole. Now consider a much larger black hole, like the one at our galaxy's center, which has a radius of about 12 million kilometers, far larger than a stellar black hole. Paradoxically, the tidal forces at the event horizon of a supermassive black hole are actually gentler due to its size. One might cross that horizon without immediate destruction or even noticing the exact moment it happened, only the complete blackness beyond. But survival is only temporary. Once inside, the fall continues inexorably. In both cases, the ultimate fate is the same, falling ever inward, deeper into gravity's domain, until one approaches the central singularity. And there, according to classical physics, one would be crushed into oblivion, merged with the mass of the black hole. Not only do black holes distort space, they distort time itself in extreme ways. For a hypothetical traveller who could hover near a black hole's horizon and then escape, time would flow much slower in their vicinity than in the rest of the universe. They might find that while only a few hours passed for them, years, or even centuries, passed for the outside world. In this way, a black hole can act as a one-way time machine to the future. A journey into its gravity well and back out would propel a traveller far into the future of everyone else. It's a startling consequence of general relativity, one that underscores just how alien the environment around a black hole truly is. It's a fate as eerie as it is final, and yet we wonder, is it truly the end? Black holes push physics to its limits, forcing us to ask questions about the nature of reality itself. Some have theorized that perhaps the core of a black hole is not a dead end, but a bridge, a tunnel through space and time. The idea of wormholes, hypothetical connections between distant points in the universe, or even to other universes, has captured imaginations. Could falling into a black hole deposit you elsewhere, somewhere else, or in a parallel cosmos entirely? It sounds like science fiction, and indeed it remains speculative. Thus far, we have no evidence that nature actually makes wormholes that survive long enough for travel. If they do exist, they might be microscopic or unstable. For now, a journey into a black hole appears to be a one-way trip to an unknown end. Black holes are dual creatures. They are agents of destruction, capable of tearing apart stars and worlds. Yet they also shape galaxies and spark some of the brightest phenomena in the cosmos. They hide whatever falls into them. Yet through their influence and the radiation from their accretion disks, they can light up the universe. They test the boundaries of our knowledge, places where gravity is so extreme that our existing theories falter. In their darkness lies the promise of new physics that we have yet to unravel. One day, a new understanding, perhaps a unified theory of quantum gravity, may reveal what truly happens at a black hole's core, or whether information that falls in is somehow preserved rather than lost forever. Intriguingly, quantum physics has also suggested that black holes might not be completely black or eternal after all. In the 1970s, physicist Stephen Hawking showed that black holes should emit a faint thermal radiation as quantum effects occur at the event horizon. Over incredibly long timescales, a black hole can slowly evaporate by radiating away its mass through this Hawking radiation. A black hole, the mass of our Sun, would take trillions upon trillions of years to evaporate, far longer than the current age of the universe. But given enough time, even these mighty dark beasts may eventually fade and disappear, leaking their contents back into the universe as subtle energy. Even with these theoretical insights, the true nature of the abyss remains elusive. Until that day comes, black holes remain one of the cosmos's most profound mysteries. As we turn away from the brink of a black hole and look back out to the wider universe, we are reminded that not all of the cosmic darkness is concentrated in these rare, voracious objects. There is another kind of darkness pervading the cosmos, something subtle and ghostly that we cannot see at all, yet it surrounds us and shapes the cosmos on the grandest scales. It doesn't form a whole or swallow light the way a black hole does. Instead, it is spread throughout space, woven into the universe like an invisible web. We call this mysterious mass dark matter, and it too is one of the great enigmas of the cosmos. Invisible mass, all around us yet hidden from our eyes. This is the paradox of dark matter. Decades ago, astronomers began to notice something puzzling about galaxies. Our Milky Way, like others, spins like a colossal pinwheel with billions of stars whirling around the centre. According to the laws of gravity, we understood, the outer stars, far from the galaxy's core, should be moving more slowly than those closer in, much as planets farther from the Sun orbit more slowly than those nearby. But when astronomer Vera Rubin measured the speeds of stars at the edges of galaxies, she found they were moving just as fast as stars closer to the centre. It was as if some extra gravitational force was present, holding those outer stars in their swift orbits and preventing them from flying off into space. Yet there was no visible matter out there to account for this strong pull. Around the same time, other observations deepened the mystery. In clusters of galaxies, where dozens or hundreds of galaxies swarm together, galaxies were moving far too quickly to be held together by the gravity of the visible matter, stars and hot gas, alone. Either our understanding of gravity on these scales was wrong, or there was a huge amount of unseen mass providing the gravitational glue. The simplest explanation was that an invisible form of matter existed in vast quantities, outweighing all the stars and gas. Astronomers began to call this unseen mass dark matter. The name is fitting. Dark matter neither emits nor absorbs light, making it invisible across the entire electromagnetic spectrum. It does not shine, nor can we directly see it with any telescope. It is utterly transparent, not just to our eyes, but to all our instruments that capture light, radio waves, X-rays, or any other form of electromagnetic radiation. And yet, dark matter's presence is felt through gravity. It acts like an invisible scaffolding throughout the cosmos. Every galaxy, including our own, is embedded in a vast halo of dark matter that extends well beyond its visible edges. When you look at a beautiful spiral galaxy in a photograph, glowing with the light of billions of stars, imagine an enormous, unseen sphere surrounding it, much larger than the galaxy itself, composed of dark matter. This halo's gravity holds the galaxy together, keeping those fast-moving outer stars bound to the galaxy. Without dark matter's extra pull, galaxies like ours would likely fly apart. Dark matter doesn't gather in dense balls or disks the way normal matter does. It's too ethereal for that. It interacts so weakly, if at all, with itself and with ordinary atoms that it spreads out in huge, diffuse clouds. One dramatic demonstration of dark matter's reality came from observations of a cosmic collision known as the Bullet Cluster. Two clusters of galaxies had crashed into one another, and the aftermath showed something remarkable. The ordinary matter, mostly in the form of hot, X-ray emitting gas, had gotten slowed down and bogged together in the middle, like mud colliding and sticking. But the bulk of the mass, deduced from gravitational lensing, had sailed through the collision unaffected, like ghosts passing through the night. This was the dark matter of the two clusters, which, being collisionless, simply kept going, It separated from the normal matter, making its presence known by how its gravity bent the light from background galaxies. Events like this provide a convincing fingerprint of dark matter, an invisible mass that can separate from visible matter, yet still exert gravitational influence. Attempts to explain these phenomena by tweaking the laws of gravity have failed to match what we see in cases like the bullet cluster. The simplest and most convincing explanation remains that dark matter is real, a substantial component of the universe that just doesn't shine. What exactly is dark matter made of? It's one of the greatest unsolved puzzles in physics. Could it be a new kind of fundamental particle, one that streams through ordinary matter without a trace? Could it be a multitude of tiny black holes left from the universe's birth, or something even stranger? At the moment, we simply don't know. We know it outnumbers normal matter by a wide margin. By the most current estimates, about 85% of all the matter in the universe is dark matter, leaving just 15% as the ordinary matter that makes up stars, planets, and people. In terms of the cosmic budget, including energy as well, dark matter accounts for roughly a quarter of the total contents of the universe. All the galaxies and glowing gas and dust we see are just the tip of a much larger iceberg of mass. To hide so effectively, dark matter must hardly interact with light or normal matter at all, aside from gravity. We already know of some ghostly particles, neutrinos, produced in abundance by stars and nuclear reactions, that barely interact with normal matter. Trillions of neutrinos pass through your body each second without a sound. However, neutrinos are too lightweight and fast-moving to account for dark matter's gravitational heft. Thus, scientists suspect a different kind of particle is responsible, something more massive but still elusive. One leading idea is that it consists of exotic particles, unlike those that make up the atoms we know. These hypothetical particles might flood the universe, passing through you and me this very second without us ever noticing. Our entire solar system is in fact moving through a cloud of dark matter as it orbits the Milky Way. Yet these particles slip through normal matter like phantoms, so we remain oblivious to this invisible cosmic ocean around us. Researchers have given them names like WIMPs, weakly interacting massive particles, or axions, and in laboratories located deep underground to shield them from interfering cosmic rays. Scientists have set up enormous detectors, tanks filled with ultra-pure liquid xenon or arrays of chilled crystals, hoping to catch the briefest wink of a collision between a dark matter particle and an atomic nucleus. So far, these experiments have registered only silence, and our most powerful particle colliders have yet to produce any promising dark matter candidate. It's as if we are chasing a ghost, but scientists press on, because the discovery of dark matter in the laboratory would be a revolution in our understanding of the universe. Each attempt that turns up empty only deepens the mystery and strengthens our resolve to keep looking. Despite not yet knowing what it is made of, we have mapped where dark matter must be. Through its gravitational effect on stars and galaxies, and by its influence on the large-scale structure of the cosmos, we can chart the distribution of dark matter. Computer simulations, powered by equations of gravity, show that as the universe evolved after the Big Bang, dark matter clumped first, forming a vast cosmic web of intersecting filaments and knots. Ordinary matter then flowed along the gravitational valleys carved by dark matter, collecting in the same places and eventually igniting as stars and galaxies. In this way, dark matter acted as the blueprint for galaxies, If we could view the universe with eyes that saw gravity instead of light, we would behold a magnificent structure, a great shimmering web or sponge, with strands of invisible matter stretching hundreds of millions of light years, and galaxies like tiny jewels glistening along these strands at their intersections. Our own galaxy is one such jewel, resting at a node of dark matter, its luminous spiral nested inside an enormous dark halo that connects to the wider cosmic web. On the largest scales, surveys of galaxies show a pattern of filaments and voids, a foam-like arrangement that matches what dark matter's influence predicts. Where dark matter is dense, galaxies collect. Where it is scarce, great cosmic voids open up, nearly empty of galaxies. The universe, seen through this gravitational lens, looks almost biological, a cosmic web stretching across unimaginable distances. The picture that emerges is that dark matter is the hidden architecture of the cosmos. It is the invisible thread upon which the visible universe is woven. Without it, the universe today would look very different. Galaxies might be smaller, more scattered, or perhaps not have formed at all in the way we know. It's humbling to realize that without dark matter's gravitational influence, the cosmos as we know it might never have coalesced into complex structures. Galaxies, stars, planets, and ultimately life could owe their existence to this hidden mass. The universe's visible marvels are, in a way, assembled and scaffolded by the invisible. Every time we measure how galaxies rotate, how galaxies cluster together, or how the universe expanded and grew, we are confronted with the undeniable influence of dark matter. And yet, because we cannot see it directly, it remains frustratingly elusive. We are like sailors on a calm sea who cannot see the wind, but can tell it's there by the billowing of the sails and the movement of the waves. One day, perhaps, we will detect a dark matter particle in a laboratory, or produce one in an accelerator, pulling back the veil on this cosmic secret. For now, dark matter reminds us how much we still have to learn. It teaches humility, that the vast majority of matter in existence is something we have never touched and do not yet understand. Still, just as we inferred its presence through careful observation and creative thinking, we continue to devise new ways to illuminate the darkness. In fact, gravity itself, this subtle force that revealed dark matter's existence, offers another avenue to probe the hidden cosmos. Through gravity, we have another messenger that can reach us from the most distant and secret corners of the universe. Not as a static pull, but as a fleeting ripple in the fabric of space-time. It is to these ripples, the cosmic symphony of gravitational waves, that we now turn our attention. For all the wonders we can see in the heavens, there are cosmic events that leave no light at all, only a trembling of space itself. When massive objects move and accelerate, they can create ripples in the very fabric of space-time. These ripples are gravitational waves, and they are the universe's most ethereal whisper, traveling across the cosmos at the speed of light. For a long time, scientists weren't sure we would ever be able to detect such waves. In the 1970s, astronomers found indirect evidence. They observed a pair of neutron stars, a binary pulsar, whose orbits were slowly shrinking in just the way Einstein's theory predicted if gravitational waves were carrying off energy. It was a strong hint that these space-time ripples were real. Still, detecting them directly would require almost unimaginable precision. Einstein himself, who first predicted these tremors in space-time in 1916, doubted that any experiment could be sensitive enough to measure them. By the time a gravitational wave from a distant collision reaches us, the disturbances it carries are unbelievably small. But in the early 21st century, Technology and patience paid off. We built instruments capable of measuring distortions in distance thousands of times smaller than an atom, on the order of 1 part in 1,000 trillion, a change smaller than the width of a proton over a 4-kilometer-long detector arm. And to the delight of scientists around the world, the universe began to sing. What exactly is a gravitational wave? Imagine space as a vast, elastic medium. When a heavy object moves suddenly, say 2 stars orbiting each other, or 2 black holes merging, it sends out waves through space, much like a stone dropped in a pond sends out ripples on the water. These waves don't travel on the surface of space. They travel through space itself, stretching and squeezing the distances between objects as they pass. If you had a very sensitive measuring stick, you would see it lengthen and then shrink ever so slightly as a gravitational wave went by. In fact, as these waves wash over Earth, the entire planet, and every one of us, is stretched and squeezed by tiny amounts. The effect is far too small for our bodies to perceive, thousands of times smaller than an atom. But with special instruments, we can detect this subtle quivering of space itself. On September 14th, 2015, such a wave passed through the Earth. It had been travelling for over 1 billion years, generated by a titanic event unimaginably far away. 2 black holes, each about 30 times the mass of our Sun, had been orbiting one another in a death spiral. They drew closer, spinning faster and faster, whipping space-time into a frenzy. In their final moments, they were moving at half the speed of light and orbiting each other several times in the blink of an eye. Then, in a violent embrace, the 2 black holes collided and coalesced into one larger black hole. The collision released a tremendous amount of energy, not as light or heat, but as gravitational waves. Space itself rang like a bell. The ripples spread outward, carrying away a piece of the cosmic event's energy and story. By the time those ripples reached Earth, they were incredibly faint. But in an observatory called LIGO, in Washington State and Louisiana, twin laser beams in long vacuum tunnels silently recorded a tiny distortion. One arm of the L-shaped detector stretched a minuscule amount, while the other arm shrank, then vice versa, exactly as would be expected if a gravitational wave had passed. The signal was a characteristic rising tone, often described as a chirp when converted into sound, lasting only a fraction of a second. Yet that fleeting whisper was enough to tell an epic tale. From the details of the signal, scientists could determine the masses of the black holes that merged, how far away the event took place, and how fast those black holes were spinning as they collided. It was the first direct detection of gravitational waves, confirming a major prediction of Einstein's theory, and opening a whole new way of observing the cosmos. In the years since that first momentous detection, gravitational wave observatories in other parts of the world have joined the effort, forming a global network of listening posts. With multiple detectors working together, scientists can pinpoint where in the sky a gravitational wave came from, much like using 2 ears to locate the direction of a sound. This proved invaluable when the era of multi-messenger astronomy dawned. Since that first momentous detection, we have listened in on the mergers of black holes of various sizes, and even the collision of ultra-dense neutron stars. When 2 neutron stars, the crushed cores of dead stars, packing a sun's mass into a city-sized sphere, slammed together in a galaxy 130 million light-years away, gravitational wave detectors caught the signal, and astronomers around the world swung their telescopes to the sky. They were rewarded with a faint glow in that galaxy, the afterglow of the neutron star crash, which produced light and heavy elements like gold and platinum. the gravitational waves and the burst of light in the form of gamma rays arrived within seconds of each other, despite having travelled 130 million years to Earth, confirming that these ripples in space-time move at the speed of light, just as Einstein predicted. This event marked the first time we both heard and saw the same cosmic event. Gravitational waves announced the collision, and then electromagnetic waves, light, let us observe its aftermath. It was a triumph of what is called multi-messenger astronomy, the coordination of different cosmic messengers to give us a fuller picture of these dramatic events. The nature of gravitational waves is profoundly different from light. They are not blocked or scattered by dust or gas. They pass through entire galaxies, as if those galaxies weren't even there. This means gravitational waves carry pristine information about the events that created them, reaching us unaltered. They can come from the heart of the most violent processes, merging black holes, which emit no light at all, supernova explosions, or even the moment when the universe was born. With gravitational waves, we have a new sense, akin to suddenly gaining the ability to hear after a lifetime of only seeing. We can now listen to the universe, complementing the cosmic vision we've long had with telescopes. In effect, astronomy gained a new sense, akin to suddenly acquiring hearing after only seeing. The cosmos, once silent, now has a voice and music that we can detect. And what we are hearing is astonishing. Each gravitational wave detection is like hearing a brief note in a cosmic symphony. Low-pitched, long notes might come from the slow spiral of supermassive black holes merging in the distant universe, while high-pitched, short chirps come from smaller black holes or neutron stars merging. With current detectors, we mostly catch the high-frequency chirps of stellar mass, black holes, and neutron stars. In the future, as detectors become more sensitive, and as new observatories, including a planned space-based detector called LISA, with arms millions of kilometers long, come online, we may start hearing the deep bass notes of supermassive black holes merging, or the faint murmurs from events in the early universe. There could be a whole orchestra of gravitational melodies out there. The continuous hum of rotating neutron stars, the chorus of many distant unresolved mergers overlapping, and perhaps the faint memory of the Big Bang itself ringing across time. The phrase cosmic symphony is more than poetic. We really do transform these wave signals into sound to analyze them. So the universe is, in a sense, making music. It's a music that no human ear can detect unaided. But with our instruments, we have brought it into the range of hearing. And it's beautiful in its own way. The first chirp from that binary black hole merger was just a simple rising tone. Yet it spoke volumes about an event that happened ages ago in a galaxy far from our own. Each subsequent detection has added new instruments to the cosmic orchestra. Sometimes a heavier black hole merger with a slightly lower pitch. Sometimes a neutron star merger with a longer, more complex chirp followed by a gamma-ray burst we can detect with satellites. Perhaps one of the most profound aspects of gravitational waves is what they imply about the unity of physics. Here we have an utterly tiny effect, a minuscule stretching of space, detected by human-made machines, caused by one of the most colossal events imaginable, the merger of black holes. It took a century after Einstein's prediction to reach this achievement, requiring extreme precision and international collaboration. It's a testament to our desire to understand the universe that we built ears sensitive enough to hear these faint echoes from across the cosmos. Gravitational wave astronomy is still in its infancy. Each new observing run of our detectors finds something unexpected or refines our knowledge of black hole populations, neutron star properties, and even the expansion rate of the universe, because gravitational waves can act as cosmic distance markers. In the coming years, as we refine our instruments, we might detect gravitational waves from new sources, perhaps the steady ripples from a rotating neutron star with a slight deformity, or the crash of a black hole swallowing a neutron star, or even signals from the tumultuous moments just after the Big Bang, fossil gravitational waves that have been travelling for nearly 14 billion years. Every time we catch a gravitational wave, we are directly sensing the motions of mass and energy far across the universe, without needing light or any intermediary. It is as if we have developed a sixth sense. We stand quietly in our corner of the cosmos, listening to the faint strains of those distant cosmic events, and from them, deciphering stories of immense power and profound significance. This leg of our cosmic journey has carried us from the discovery of new worlds circling other suns, through a deeper understanding of gravity's true nature and its most extreme manifestations, to the invisible scaffolding of dark matter, and finally, to these gentle gravitational harmonies that reach us across space and time. Each topic has brought us face to face with the unknown and the wondrous. As the cosmic symphony plays on, we find ourselves attuned to the subtle and grand alike, the quiet tug of an unseen mass, the roar of colliding black holes echoing as a faint chirp, the silent presence of invisible matter, and the delicate balance of worlds beyond our own. Taken together, all these revelations paint a richer, more intricate portrait of reality. We have learned that other suns host other worlds, some potentially like our own, expanding the horizons of where life might take root. We have seen that space and time are interwoven and alive, bending around mass and even ringing with cosmic vibrations from cataclysms across the universe. We have confronted the abyss of black holes, gravity's ultimate triumph, and found them both destructive and generative, lighting up the cosmos as they feast. We have acknowledged an invisible scaffold of dark matter without which the galaxies would not hold together, a silent partner in the cosmic dance. And we have opened our ears to the gentle music of gravitational waves, giving us a new sense with which to experience the universe. Each discovery stands on its own as a marvel, yet they all connect, each phenomenon influencing the others in the grand cosmic web. Every insight we gain into one aspect of the universe helps illuminate another, bringing us closer to a unified understanding of nature's deepest laws. These are the secrets of the universe we have begun to uncover, and yet so many mysteries remain. Each discovery we make opens a dozen new questions. But that is the beauty of science. There is always more to learn, and the journey itself deepens our appreciation of the cosmos. With curiosity and awe as our guides, we will continue onward, deeper into the cosmos, eager to discover what other marvels await beyond the horizon. Yet, standing here on our small planet, under the endless stars, we feel a profound gratitude and awe. The universe is vast and full of secrets, but with each passing generation, we peel back another veil. Bit by bit, we are learning the story of the cosmos, and in doing so, we are coming to understand ourselves. Our journey continues onward, with the next chapter waiting among the stars. Just as we have looked out into the vastness of space and felt a grand unity, we now turn inward into the minuscule to find wonders no less profound. Our journey continues seamlessly, from the very large to the very small, for the two are connected like reflections in a mirror. At the smallest scales of existence, a new kind of mystery and wonder unfolds. As we shift our gaze from the immense to the infinitesimal, we enter the realm of the quantum, a world where the rules of everyday reality seem to fade into a dreamlike haze. Here, particles flicker in and out of being, and certainty dissolves into possibilities. In this microscopic domain, we find that everything solid is mostly empty space, and what we think of as matter is composed of tiny, flickering energies, whirling in vast gaps of apparent nothingness. It is as if the cosmos, when examined up close, is built not of bricks, but of whispers and probabilities. Imagine shrinking down into an atom, drifting past electrons that swarm not like planets around a sun, but like a diffuse cloud of potential, here and there at once, until observed. In this tiny universe within the universe, an electron can be almost everywhere and nowhere in particular. Only when we try to pin it down does it seemingly make a choice of where to be. This is the strange dance of quantum mechanics. Particles behaving sometimes like solid points, other times like spread out waves. A single speck of light, a photon, can act as if it travels many paths simultaneously, then settles on one path when we look. Reality at this level is not a fixed storyboard, but an improvisation, a play of light and shadow that only becomes concrete when it interacts with a consciousness or a measuring instrument. It's a realm that invites us to question what is truly real and whether observation is woven into the very fabric of existence. This isn't chaos, but a different kind of order, one that defies our common intuition. In quantum realms, cause and effect can feel less straightforward. Two particles born together can become entangled, a mysterious bond connecting them no matter how far apart they fly. If one is gently nudged, the other responds, even if it is across the room or across the galaxy, instantaneously as far as we can tell. It is as though the universe keeps secret channels between distant things, a private whisper that ignores the vast gulf of space. Experiments have shown this spooky connection to be real. Einstein himself famously nicknamed it spooky action at a distance, acknowledging how unsettling such instant linkage was to him. Yet every experiment since has confirmed that this phenomenon is indeed real. It suggests that separateness might be an illusion, and that at a fundamental level, the cosmos is deeply interconnected in ways we are only beginning to fathom. In the quiet of our journey, think of what this means. The very particles in your body might have subtle links to particles far away. Perhaps an atom in your hand is quantum connected to an atom in a star 1,000,000 light years distant. While the specifics of entanglement don't persist in our complex bodies, the idea symbolizes a truth, that everything emerged from the same cosmic beginnings. In the moments after the universe was born, all was one blazing soup of particles intermingling. As the universe expanded and cooled, those particles drifted apart to become galaxies, stars, planets, and eventually us. Yet on an underlying level, they remember a time when they were together as one. The echo of that unity may still live in the quantum language they speak. Not only distance, but time too, behaves oddly in the quantum world. Particles pop into being and then vanish, as if borrowing energy from the future and returning it an instant later. This constant fluctuation, sometimes called quantum foam, means even empty space is teeming with subtle activity. What appears as a void is more like a sea of virtual particles, momentarily alive, then gone again, like transient thoughts in the mind of the universe. Perhaps this is the source of creativity in nature, the way new possibilities emerge. From this foam, entire universes might have budded off, or the seeds of galaxies might have been sown. On a smaller scale, these tiny fluctuations are happening around us and within us all the time, unnoticed yet essential. They provide a backdrop of possibility from which more stable things, like atoms and molecules, can form and persist. And within the heart of a star, quantum magic enables life-giving light. In the sun's core, where temperatures and pressures are immense, atomic nuclei fuse together, releasing energy that eventually radiates out as sunlight. But curiously, the nuclei in stars are often not energetic enough on their own to overcome their mutual repulsion. It is the quantum trick of tunneling, the ability of particles to slip through barriers as if by ghostly permission, that allows the sun and stars to shine. Two hydrogen nuclei can fuse into helium because, in the quantum realm, there is a small chance they simply find themselves together, bypassing the usual obstacle. Without this tiny chance, the stars might never ignite, and the cosmos would be dark and lifeless. Thus, the everyday sunshine that warms your skin is rooted in the uncertainties of the subatomic world. The quantum and the cosmic are intimately linked, each dependent on the other to exist in the form we know. Consider for a moment that your own existence hinges on these delicate improbabilities. The particles in your heart and brain obey these strange laws. At every moment within you, electrons jump in atoms. Enzymes facilitate reactions by quantum quirks. Even the very sense of smell you have might involve electrons tunneling in receptors. We go about our lives unaware that the utterly bizarre is happening in every cell. Yet here we are, large and stable, classical creatures in a quantum-built body, marveling at the stars. It is as if nature hides its magic beneath a veil of normalcy, so that we can live and wonder without being overwhelmed by constant paradox. But on nights like this, while contemplating the cosmos, that veil thins just a little. We remember that the ground of reality, the foundation of everything, is a mystery that transcends full comprehension. Some have even wondered if consciousness itself might be tied to this quantum strangeness. Could it be that the mind, in its ability to leap from one thought to another, or in the feeling of free will, has something quantum about it? It's a speculative idea, yet intriguing to think that the gap between an intention and an action might be a kind of quantum jump. Whether or not that is true, what we do know is that our brains operate with electrical impulses and chemical signals that are ultimately governed by those same microscopic rules. So in a way, the thoughts you have, even this very experience of calm reflection, are enabled by subatomic particles doing their quantum dance within your neurons. We are quantum beings as much as we are cosmic beings. The dual nature of particles, behaving as both material and immaterial, has a philosophical echo. We too are flesh and spirit, physical yet filled with intangible feelings. The quantum world shows us that reality is not simply material or energy, but something more subtle, something that can manifest as solid matter or as spread out potential. Similarly, within us there are tangible aspects like our bodies and intangible ones like dreams, thoughts, and consciousness. Perhaps the line between what is physical and what is not is more blurred than we imagine, just as the line between particle and wave is blurred for a photon. In the smallest spaces, the categories we take for granted break down, inviting us to embrace uncertainty and paradox as fundamental parts of nature. All of this might sound bewildering, but in the gentle context of our cosmic journey, it can also be quietly wondrous. It tells us that there are layers of reality stacked in ways our senses alone cannot reveal. If the cosmos were a grand mansion, our everyday experience is like living in just one beautifully furnished room. Science has opened doorways to other rooms, showing us that beyond our normal view there are wonders, some that behave like funhouse mirrors, where up can seem down, or like secret passageways connecting distant halls. It's as though the universe enjoys a bit of playful mystery, keeping surprises tucked away in the very structure of existence. As our minds absorb these reflections, let us gently step back from the quantum world. We zoom out from the tiny atoms and return to the realm of the visible and tangible. See in your mind's eye the scene expanding, from subatomic particles to atoms, to grains of sand, to a human hand, to an entire person, to the environment around them, and finally back to the open night sky overhead. The stars still sparkle calmly, seemingly unchanged by the bizarre truths we uncovered beneath the surface. And indeed, for ancient travellers and poets, these hidden details were unknown. What they experienced was a sky of reliable patterns, guiding lights that turned with the seasons, year after year, faithful and familiar. So now, as if rising from that subatomic reverie, we turn our attention back to the human scale under the open sky, to the wisdom of those who came long before, who navigated the cosmic seas without ever knowing the word quantum, but who connected to the cosmos through stories and practical knowledge of the stars. Long before modern instruments and charts, humans learned to read the night sky as if it were gentle instruction from the cosmos. Imagine a vast ocean centuries ago. A Polynesian voyager stands at the helm of a canoe carved from an ancient sacred tree. All around is the dark water below, and above an astounding sprawl of stars. There is no land in sight, only the swell of waves and the dome of heaven. Yet this voyager is not lost. As the sun set, they noted the first star to appear on the horizon, a familiar friend marking the direction of home. Through the night, they will navigate by the rising of specific stars, each guiding them along a memorized path across the sea. With no compass but the sky itself, they trust in a map written in starlight, passed down through generations. In the gentle rocking of the canoe, one can almost feel how the navigator's senses extend beyond the boat. The sailor feels the pattern of swells against the hull, the cool wind shifting, and overhead the constellations slowly rotate. They carry in their mind a starry compass, a mental chart of where key stars rise and set along the horizon. As one guiding star climbs high and drifts westward, the voyager's eyes move to the eastern horizon for the next star that will take its place in guiding the way. All through the night, this relay of stars keeps the canoe on course. The voyager might softly chant an ancient song that names each star and its role, the melody itself a tool to remember the route. There is serenity in this wayfaring. The ocean and sky are not adversaries, but trusted companions on the journey. The North Star, called Polaris, has long been a steady beacon for travellers in the northern world. In the sky, it barely moves at all, holding nearly still while the other stars wheel around it. For sailors and wanderers, this fixed point offered reassurance, a cosmic lighthouse shining no matter how dark the night. Many a traveller has looked up, found Polaris, and felt a wave of relief, knowing the direction of north with certainty. In the southern hemisphere, where Polaris is not visible, navigators turned to the Southern Cross, a cross-shaped grouping of stars, and the two pointer stars near it to infer the location of the south celestial pole. Even without a single bright star to anchor the sky, the pattern of those stars provided a reliable guide. No matter where one stood on Earth, the sky was a compass for those who knew its secrets. These techniques were often safeguarded and taught within families or guilds of navigators. In some cultures, the knowledge was considered sacred. After all, the ability to cross a vast ocean and return was a matter of life and death. It required not only skill, but a profound relationship with nature. The navigator had to attune themselves to subtle cues, the colour of the twilight, the pattern of swells which might hint at faraway land, the flight paths of birds at dawn, returning to roost on islands beyond the horizon. Each sign was read in conjunction with the stars. It is a testament to human ingenuity and trust in the cosmos that people voyaged for thousands of miles this way, long before sextants or modern navigation tools. Consider an image of an elderly Pacific Island wayfinder teaching a young apprentice beneath a dome of brilliant stars. They lie on their backs in a canoe moored in calm lagoon waters, the elder's weathered hand pointing out the star paths. With each gesture, they recount a story, how this star was named for a particular ancestor, how that constellation looks like a fishhook, used by a demigod to pull up islands from the sea. The apprentice listens and watches, eyes tracing the invisible lines drawn by the teacher's words connecting star to star. They feel the warm night air and hear the gentle lapping of waves, absorbing the knowledge that will one day keep them alive on the open ocean. In teaching navigation, myth and practical wisdom merge seamlessly. The stories serve as both mnemonic and moral, embedding crucial navigational cues in narratives that can be easily remembered and passed on. And indeed, for people everywhere, the night sky became a grand tapestry of stories. Long before books or television, our ancestors looked upward for storytelling inspiration. They saw figures of legend among the stars, heroes, monsters, gods, and animals, their dramas playing out night after night in slow motion as the seasons changed. Which stars were visible? The patterns we call constellations were like a global picture book, with different cultures drawing different pictures from the same points of light. What one group saw as a great bear, another imagined as a mighty hunter, and yet another as a celestial canoe. For example, in Greek mythology, the constellation Orion is seen as a great hunter with a shining belt of 3 stars. He chases eternally across the sky, accompanied by his faithful dog, the star Sirius, brightest of the night. To the ancient Greeks, Orion's setting, when he dipped below the horizon, signified the time of year when scorpions, represented by the constellation Scorpius, on the opposite side of the sky, rose, as if the scorpion that once stung him still pursues him among the stars. Meanwhile, many Pacific Island cultures saw a different picture in some of those same stars. In one Polynesian interpretation, Orion's belt and the stars around it form the outline of a great canoe. In this way, the heavens reflected their seafaring life. The Pleiades star cluster is another celestial wonder, wrapped in story. To the naked eye, on a clear, dark night, one can see 6 or 7 tiny stars clumped close together, like a little sprinkle of diamonds. Almost every culture noticed this cluster and wove tales about it. To the Greeks, these were the 7 sisters, daughters of a Titan, placed in the sky to hide from a great hunter, or perhaps to mourn a lost sibling, depending on the tale. In Maori tradition in New Zealand, the cluster is called matariki, and its rising in winter marks the beginning of the new year, a time of remembrance and planting for the coming spring. In Japanese, it is Subaru, a name you might recognize, as even a modern car brand pays homage to the cluster's unity of stars. In many Native American traditions, there are stories of 7 children or friends who became those stars. One beautiful tale from the Cheyenne people tells of 7 children who fled to the sky to escape a ferocious bear, becoming the Pleiades, and the bear became the nearby bowl of the Big Dipper. Such stories, while varied, show how universally this little cluster captured human imagination. When people far apart in time and space all felt compelled to explain the same tiny pinwheel of stars with a story, it underscores a shared human desire to connect the dots of the sky into something meaningful. The Milky Way itself, the pale ribbon of diffuse light arching overhead, was often interpreted as a path or a river. Some called it the River of Heaven, imagining that souls travelled along it to the afterlife, or that gods crossed it as a shimmering bridge. Others saw it as spilled milk from a goddess, or the strewn hay from a celestial horse's feed. In a Chinese legend, it is the silver river that separates 2 lovers, the star Altair, a cowherd, and the star Vega, a weaver girl, who are allowed to meet only once a year when a bridge of magpies forms across the Milky Way, allowing the lovers to reunite. That story is still celebrated on a summer night each year, when people look up and remember the separated lovers in the sky. Meanwhile, in a different land far away, people told a very different kind of sky story. In Australia, some Aboriginal peoples focus not on the bright Milky Way stars, but on the dark patches between them. Against the glowing, starry band, they see the shape of a great emu stretching across the sky. The emu's head is a coal-black nebula near the Southern Cross, and its body follows the Milky Way's misty path. This sky emu is woven into their traditions. When it appears in a certain posture at dusk, it signals the season to gather emu eggs. The dark voids of the galaxy become a giant bird in their imagination, connecting the cosmos to their way of life. This creative vision shows that human imagination finds meaning not just in the stars, but in the darkness between them. Through stories, the stars became more than just lights. They became reminders of lessons, of morals, of cycles of nature. A constellation representing a heroic figure might remind people of courage during difficult times. One representing a farming tool or a beloved animal might signal when to plant crops or hunt game. The sky was a calendar and a compass, combined with a storybook, as useful as it was inspiring. Myths served multiple purposes: entertainment, moral guidance, and practical knowledge, all encoded as one. Consider the experience of a child in ancient times, looking up on a clear night while an elder points out constellations and recounts their tales. The child's eyes move from star to star as figures come alive in imagination, perhaps seeing the mighty outline of Orion or the curved tail of a scorpion. They hear how those stars came to be, maybe a story of love or of bravery or a great transformation. In those moments, the child is not only learning the map of the sky, but also absorbing a sense of belonging to a larger narrative. They learn that the same stars were watched by their ancestors, that the same tales have been passed down through generations, and thus they too are part of this continuity. The stars tie generations together, as each retelling of a constellation's story rekindles the memory of those who first told it. And all the while, the night gently turns. The earth rotates, and new stars rise in the east, while others set in the west, making the sky dynamic. Over months, the constellations shift with the seasons. Our ancestors noticed this, and the sky became their seasonal clock. The appearance of certain stars at dawn or dusk signaled planting or harvest times, the migration of herds, or the flooding of great rivers. For example, the ancient Egyptians watched for the rising of Sirius just before sunrise, an event that heralded the annual flooding of the Nile, so crucial for their agriculture. To them, that star was linked to the goddess Isis and to the cycle of life, death, and rebirth of the land. Thus, mythology, agriculture, and early astronomy intertwined. Navigators, storytellers, farmers, and priests alike studied the sky, albeit with different aims. But whether they sought to find their way across open ocean, to explain the mysteries of existence through tales of gods, or to predict the changing of seasons, they all treated the sky as a trusted guide. It loomed above as a constant presence that anyone could observe. Over generations, careful observation and rich imagination turned into traditions of knowledge. Even today, there are those reviving and practicing these ancient arts. In the Pacific, voyagers have once again begun to sail canoes without modern instruments, trusting the stars, waves, and winds as their ancestors did, proving the old ways still hold. Such journeys are as spiritual as they are technical, reaffirming a bond with nature and heritage. We might think that in modern times, we have moved beyond those star stories, replacing them with scientific fact. But on a quiet night, even now, if you gaze long enough, you might find your mind drifting into those old patterns, seeing the shape of a hero here, a mythical creature there, or recalling a legend you heard once about a constellation. Our fancy for stories never truly leaves us, because it's woven into how we perceive patterns and meaning. In its own way, science maintains continuity with these ancient impulses. Both are driven by curiosity and the urge to find connections. Where an ancient myth maker connected stars to craft a tale, a modern astronomer connects data points to form a theory. Both are creating narratives to describe and predict the workings of the world, one through imagination, the other through mathematics and observation. Under the stars, the boundary between practical navigation and spiritual journey often fades. Many cultures believed that gods or spirits literally inhabited the stars, or that ancestors became stars when they passed on. A voyager might have felt their ancestors watching over them in the sky, guiding them along. The night sky could be both compass and cathedral, a place of direction and of worship. Even today, away from city lights, one can feel a natural reverence while gazing up. It is as if something in our very old memory recognizes the importance of that view. We might not remember the specific star lore of our distant forebears, but the feeling of wonder and respect is ingrained. Now, as the ancient stories and methods swirl in our thoughts, we can appreciate how human understanding of the cosmos evolved. We moved from seeing patterns and telling tales to measuring and hypothesizing. Yet we should not think of it as discarding one for the other, but rather adding layers. The starry sky that once solely told myths now also tells us about galaxies and physics. But the myths can still live on in our cultural heritage. In a way, the cosmos has always been a canvas for our minds. What changed over time were the brushes we used, painting first with mythic imagination, later with scientific reasoning. Ultimately, both pictures reflect our desire to engage with the cosmos. Humanity's relationship with the stars has been both practical and poetic. The night sky guided our voyages and also our dreams. With those dreams in mind, we drift onward, from the tales of old to the ways we seek understanding today, blending myth and science in the ongoing story of our connection to the universe. For centuries, myth and science have danced around each other like twin stars orbiting a common center, the human desire to understand. Myths were our first brave attempts to explain the bewildering and the beautiful. Before we had equations, we had stories. When thunder roared, we spoke of gods. When comets streaked the sky, we imagined dragons or omens. These tales were not foolish. They were our early wonder given narrative form. They comforted us, taught us, and piqued our curiosity. They also spurred practical knowledge. Ancient peoples marked the passage of seasons by the stars. They built great circles of stone and pyramids of rock aligned with celestial events. Think of Stonehenge in England, catching the sunrise of midsummer, or the pyramids in Egypt, oriented to the north, like giant compasses, or the temples of the Maya, precisely tracking the cycles of Venus. Such structures required careful observation and record keeping, an early scientific mindset inspired by the skies. Even without modern instruments, our ancestors mapped the heavens with remarkable accuracy, blending their mythic narratives with empirical timing. The sky was their textbook and their scripture both. In truth, the boundary between myth and science is porous. We often personify scientific concepts in cosmic terms. We speak of the angry red planet Mars, or the elegant dance of binary stars, or the generous sun giving life. These metaphors are little mythic flares in our language, acknowledging that there is poetry even in facts. We name constellations after ancient heroes and planets after old gods, as if deep down we know that myth and science are both part of one continuum of meaning. We even send our scientific creations to the heavens, bearing mythic names, rockets named for Saturn, spacecraft named Apollo or Juno, rovers named for goddesses of the dawn. It's as though we cannot resist linking our newfound knowledge back to familiar stories, because those stories are our cultural heartbeat. Consider how every scientific theory truly begins as a spark in the mind. Newton watching an apple fall and pondering if the moon falls around the earth in the same way. Einstein picturing himself riding on a beam of light. These pivotal moments were acts of imagination. They became science after rigorous thinking and testing, but they started in the realm of creativity, not so different from dreaming up a myth. And like myths, sometimes scientific ideas sound incredible at first. The Earth moving around the sun, invisible forces of gravity, time that slows down or speeds up, holes in space that swallow even light. These could be plot points in a fantastical story, yet they are our reality, proven and accepted, but no less wondrous. In communicating these discoveries, scientists often must become storytellers themselves, crafting narratives that guide others to understand truths that are not immediately visible. Our modern explanation of the universe's origin, the Big Bang, is itself a kind of creation story. Instead of gods forging the world, we have a tiny hot seed that expanded outward, cooling and spawning galaxies and stars over billions of years. Instead of a single generation of deities, we have multiple generations of stars, giving birth to heavier elements in their fiery cores and spreading them in supernova explosions, from which new stars and planets form. We tell of how our sun and earth coalesced from a swirling nebula, how life sparked in the oceans, how consciousness lit up in creatures that could then look back and begin to tell the story. This grand narrative is pieced together by evidence and reason, but we string those pieces into a timeline that humans can grasp. A story with a beginning, however mysterious, a dramatic unfolding and ongoing chapters. There is even a hint of destiny in how conditions had to be just right for life, echoing anthropic musings that the universe in some way knew we were coming, though science, of course, frames it as a fortunate coincidence filtered by vast numbers. Yet science is careful. It reminds us that unlike fixed myths, its stories are provisional. If new evidence arrives, the story changes. Once, we thought the expansion of the universe might be slowing. Now we observe it is accelerating. And so our cosmic story gained a new mysterious element: dark energy, an unknown force driving galaxies apart faster and faster. In mythic terms, one might call it an invisible spirit of expansion. In scientific terms, it's a puzzle to solve. Either way, we acknowledge there is something fundamental we don't yet understand, and we give it a name so that we can talk about it. Dark matter and dark energy. Even the act of labeling them dark reflects that we're reaching for metaphors to describe what is essentially the unknown. These are our modern mysteries and wonders, as profound as any ancient riddle. We have detected their influence, yet their true nature remains elusive. It is as if the cosmos is keeping secrets, ensuring that wonder and discovery are never-ending. Just as myths spoke of hidden forces and unseen realms, science now speaks of dark ingredients of the universe that challenge our understanding. We give them names as placeholders, but they humble us, reminding us that for all we have learned, there is vastly more we do not know. Perhaps future generations will unravel these secrets, turning the unknown into the known, and finding new mysteries beyond, continuing the grand story. Imagination fuels both art and science. A cosmologist imagines how space might curve and warp, just as a painter imagines new worlds on a canvas. When we build telescopes to peer deeper into space, it's like adding new chapters to our cosmic story, filled with images that astonish us. Galaxies colliding, nebula glowing with newborn stars, black holes with swirling disks like cosmic whirlpools. We often give these sights poetic nicknames too: the pillars of creation, the eye of God, nebula, the butterfly nebula, as if we try to tame the raw data with a touch of familiar beauty. The reality of these phenomena is purely natural, but our perception layers meaning and wonder on top, much as we always have. Think of how star lore and science education coexist today. A teacher might begin a lesson by recounting how the Navajos see the Milky Way as a path of spirits, and then segue into how it is composed of billions of stars. The interplay makes learning rich and keeps our sense of wonder intact. We do not have to choose one or the other in our hearts. We can appreciate the scientific explanation while still feeling the poetry of the older tale. In fact, sometimes knowing the science deepens the awe. When we learn that the colours of a sunset come from light scattering in the atmosphere, we might simultaneously recall a legend of the sun being painted by a god's hand, and hold both thoughts with a smile. One foot in factual understanding, one in imaginative appreciation. Modern storytelling continues to expand our cosmic imagination. Through books and films, we conjure scenarios of interstellar travel, encounters with alien life, journeys through time. These are our new myths, projected into the future instead of the past. But they serve a similar role. They let us explore possibilities safely in the theatre of imagination. What if we could sail among the stars as ancient mariners sailed the seas? What civilizations might exist on worlds circling those distant suns? These fictions spark the public's interest in actual science. Many scientists trace their inspiration back to a childhood book or movie that ignited their passion for the stars. In that way, storytelling helps propel understanding forward. Dreamers imagine it, and later someone tries to build it. Indeed, the boundary between fantasy and reality is porous. Humans dreamt of flying to the moon long before rockets existed, and then one day, those dreams guided us to set foot on the lunar surface. What was magic became science. As we stand at the shore of the unknown, we carry with us this blending of narrative and knowledge. Throughout history, there have been moments when myth and science converged or collided directly. When Halley's Comet returned in 1910, some feared it as a bad omen, echoing ancient superstitions, while astronomers calmly calculated its trajectory and understood it as a natural event. When we first saw the surface of Mars through telescopes, some imagined canals built by Martians, blending observation with fanciful interpretation. That particular imaginative leap turned out to be incorrect, but it led to countless stories that in turn inspired real scientific searches for life on Mars. Even today, when a scientist ponders multiverse theories, the idea of countless unseen universes with different realities, one might say we are touching ancient ideas of innumerable other worlds or realms, akin to myths of other dimensions or spiritual planes. If the multiverse exists, then reality is layered beyond comprehension. Each universe, a bubble with its own stars, and perhaps its own forms of life. An endless foam of creation. It remains a scientific speculation, but it's a profound reminder that however far we push our understanding, there may always be more, an ever greater context that we have yet to glimpse, an ever wider horizon of existence. In that sense, the daring leap of vision is similar across ages. We continually expand our conception of what might be, guided by both wonder and reason. There is a sort of harmony in acknowledging both sides of our nature, the analytical and the imaginative. Alone, science can become dry, and myth can become baseless. Together, they enrich one another. When the night sky makes us feel something profound, that is the domain of poetry. When we then measure the spectra of starlight to find their elements, that is science. Feeling and understanding, Both are essential to a full relationship with the cosmos. We are not robots cataloguing stars, nor are we only dreamers ignoring facts. We are both, a species that uses mind and heart together. So as we gaze at the stars tonight in our journey, we carry with us both ancient and modern wisdom. We can admire Orion as the hunter of legend and as a glittering assembly of stars hundreds of light years away, including red Betelgeuse nearing the end of its life and blue Rigel shining hot and young. Knowing these facts doesn't diminish the constellation's allure. If anything, it adds another layer of meaning. The cosmos grows more complex and yet more personal the more we learn. Each discovery is like finding a new piece in an endlessly rich story. Let us also reflect on ourselves as storytellers. We have been doing it this entire time. This very narration is a form of storytelling, weaving facts and reflection together into a tale to share with you. In telling the story of the universe, we are engaging in one of humanity's oldest pastimes, passing knowledge and wonder from one person to another. Whether gathered around a campfire or through the medium of a screen or speaker, the essence remains the same. One being says to another, "Listen, I have seen something amazing. Let me share it with you." In this way, each of us becomes both student and teacher of the cosmos, inheriting wonder from those before us and gifting it to those after us. As we prepare to explore the next realm of experience, the night has deepened and the outer world grows still. It is a natural time to turn inward. Let's hold close this union of myth and science, of imagination and reason. They will accompany us as we turn inward now to the realm of inner exploration, where the stories we tell meet the stories we live, and where the boundary between the universe out there and the universe within grows ever thinner. Our journey through the cosmos has carried us across countless wonders, luminous, ethereal nebulae, swirling galaxies, and distant worlds. Now, as we drift further into the quiet, star-washed reaches of space, a gentle cosmic silence surrounds us. The stars glimmer like distant lanterns set in a deep velvet expanse, and the band of our Milky Way arches overhead like a faint glowing river. With no sound but the beating of our hearts and the whisper of our own thoughts, we feel truly afloat in the cosmic ocean. In this stillness, the vastness and mystery of the universe invite a deeper, more contemplative reflection. We find ourselves not just observers of the stars, but participants in a grand cosmic story, entwined with the very fabric of the night sky. Beneath an endless vault of stars, a sense of cosmic consciousness awakens. It is a subtle awareness that we who gaze up at the galaxies are made of the same luminous dust that twinkles above. The atoms that form us were born in ancient stars, and in our minds flickers the light of those long vanished suns. We are more than small beings lost in the void. We are the universe itself, perceiving its own immensity through human eyes. On a moonlit night, far from city lights, one can lie back on cool grass and feel the infinity overhead. The Milky Way spills across the sky, and in its silvery glow comes a whisper of connection. Each star above is a distant sun, and around some of those suns may circle planets with their own seas and skies. Perhaps on a faraway world, under an alien sky, another soul looks up and feels the same wonder. They might have 2 moons, or a sky tinted in unfamiliar colours, but the stars above spark a familiar question in their heart. In their own way, they wonder if someone else is out there, just as we wonder about them. For that distant observer, we ourselves are part of the mystery of the universe, just as they are for us. In that thought, the cosmos seems to grow smaller and more intimate, like a neighborhood of houses under one shared sky. We do not yet know whether such distant neighbors truly exist. The universe has been silent so far about other beings. If, in the vastness of space, we are the only ones who have awakened to awareness, then our role is singular and profound, to be the universe's lone conscious voice, cherishing this gift of insight. If, on the other hand, the cosmos is teeming with life, then one day our awareness may meet another's, and the universe will know itself in a new collective way. Either possibility fills the heart with wonder. In the meantime, the night sky keeps its quiet secrets, and we continue to send out our thoughts and probes as greetings in the dark. With each message we beam outward, and each listening ear turns skyward. We affirm hope that we are not alone. And even if we are alone for now, the cosmos we are a part of is rich enough in marvels to keep us company. This feeling of unity can arise in such quiet moments. As you inhale under the night sky, the air filling your lungs carries atoms exhaled by ancient trees and forests, atoms that drifted through clouds and across oceans to reach you. Those atoms have been part of countless forms of life before finding their way to you. In the same way, the starlight that falls gently on your face has travelled years or millennia to reach this very moment. When it touches you, you become the meeting point of past and present, of distant stars and the earth beneath you. A calm sense of awe and reverence may dawn. You are an essential part of this vast, ever-unfolding cosmic tapestry. We often think of the universe as something outside and separate, a panorama we observe from a lonely shore. Yet consider that the boundary between out there and in here is delicate. The photons from a star enter your eyes and become tiny electrical signals in your brain. In that instant, a piece of a star has become part of your inner world, of thoughts and feelings. The cosmos pours into us ceaselessly through every sensation and every breath. In turn, we project our dreams and questions back out into the cosmos, sending probes and prayers, radio signals and radiant hope. There is a continuous exchange, a conversation between the universe and our own awareness. In the stillness of a clear night, such thoughts flow naturally. One might recall lying by a crackling campfire under a canopy of stars, feeling both incredibly small and profoundly connected. The stars seem to listen to the quiet of your mind. In that silence, you may sense that your own consciousness is like a mirror, reflecting the cosmos back to itself. After all, every idea we have about the stars comes from within the mind that evolved here on Earth, a tiny world orbiting a modest star in a galaxy among billions. And yet that tiny mind can envision the entire cosmos. It can ponder eternity and infinity, as though inside us we hold an echo of the boundless sky. Across the ages, humans have wondered whether the universe itself could be conscious in some way. When we look out at galaxies swirling like giant storms of stars. A few have fancied that those might be thoughts in the mind of the cosmos. This may be just poetic imagining, but it springs from a real sense of mystery and wonder. We find consciousness in ourselves to be the most immediate reality. We know without doubt that we are aware, even if we do not fully understand how. And we see the organized complexity of the universe, from galactic clusters down to living cells. And we wonder, is it all mere coincidence, or is there an underlying awareness threading through the cosmos as well? Science does not yet have an answer to the deepest questions of consciousness. But on a calm night, under the stars, one doesn't need an answer to feel a connection. It can feel as if the cosmos knows you, in the simple fact that it made you. The carbon in your muscles, the calcium in your bones, the iron in your blood, all were forged in the hearts of stars that lived and died billions of years ago. Those stars are gone, but a part of them now thinks and feels and gazes up at the sky again. In that sense, the universe has recycled itself into living form, capable of awe. Through our eyes, the universe beholds its own ancient light. Through our ears, it listens to the cosmic silence. In our hearts, perhaps it feels a little of its own immensity. Consider a single speck of iron in your blood, an atom riding within a red blood cell on its circuit through your veins. Where did it come from? Long ago, that iron atom was forged in a star's core in a fantastically hot furnace. When that ancient star reached the end of its life, it exploded in a brilliant supernova, scattering its elemental riches into space. That iron atom drifted through the galaxy as part of a gas cloud for millions or perhaps billions of years. Eventually, that cloud became part of a new star system, our solar system. In the young Earth, that atom mingled in rocks and soil. Through geological ages, it might have been washed into the ocean, or drawn up into a plant, and then eaten by an animal. Ultimately, it found its way into your body, perhaps in the food you ate, or the water you drank. Now it travels inside you, helping to carry oxygen to your cells. In time, when your journey of life is complete, that iron will return to the earth, and perhaps far future generations, or even new worlds, will carry it onward. This one tiny atom has crossed the cosmos and eons of time to be part of you, a bridge between your life and the stars. Multiply that story by trillions, for every atom in you has a tale just as astonishing. Realizing this, the line between you and the universe begins to blur, as indeed it should. This perspective can bring both comfort and curiosity. If we are the universe aware of itself, then when we love, when we create art, when we explore, it is the cosmos expressing those very things through us. Every poem written about the stars, every equation scribbled to understand gravity, every lullaby sung to a child under the night sky. These are acts of the cosmos understanding and cherishing itself. We often feel so separate and small, but in truth we carry the universe within us. Not just in the physical sense of being made of star stuff, but in the sense that our capacity for thought and emotion is as natural a part of the cosmos as the burning of a sun or the orbit of a planet. Picture the first humans who realized that those tiny lights above are not just holes in a black curtain, but distant suns blazing far away. Imagine the amazement, and perhaps the fear they must have felt, sensing suddenly that the world is so much larger than it seems. But with that realization, also came a profound opportunity for humility and connectedness. To know that the atoms of our bodies come from the stars can instill a deep sense of belonging in the universe. We are children of the cosmos, made from its raw elements, and to it we shall return when our lives end and our atoms disperse to become new forms. This cycle of matter is like a great wheel turning slowly over eons, life and death, stars and galaxies, all bound together. So, on this journey, as we float through the quiet, starlit void, consider that you are both a traveller and already at home. You voyage through space on a tiny planet, yet you also carry within you pieces of every place you have ever been. In a way, you are home to particles of distant stars, and perhaps even distant galaxies, which drifted through the cosmos and eventually became part of the Earth. The cosmos is not just around you, it is within you, sleeping in your cells, awakening in your thoughts, and breathing in your breaths. With each gentle inhale and exhale, you trade atoms with the air and the world, blurring the line between you and the outside. Over a lifetime of breaths, you will inhale trillions of atoms that once belonged to others, other people, other creatures, even other worlds. And those others, in turn, will inhale atoms that were once part of you. In this great exchange, the universe mingles itself, all things sharing the same cosmic air. This awareness can become a kind of meditation. Breathing becomes not just a simple act of survival, but a communion with ancient elements. Looking at the stars becomes not just sightseeing, but greeting ancestral lights that are kin to our very substance. A gentle breeze on your skin at night might remind you that the atmosphere wrapping around our world is itself a product of life, interacting with cosmic forces. The oxygen from ancient trees, the nitrogen from long ago stellar events, all blending to cradle us. We are cradled not only by the Earth, but by the cosmos at large. Starlight, gravity, and elemental cycles nurture us each moment. And in gratitude, we pay attention. We listen to the night. The cosmos has a way of inviting our attention inward, even as we gaze outward. In the darkness, as your eyes adjust, more stars emerge from hiding. Likewise, as you become still, thoughts settle, and a deeper sense of self can emerge from within. It is in those moments that the concept of cosmic consciousness becomes more than an idea. It becomes a felt experience. Perhaps you notice that your heartbeat is steady and calm, echoing gentle rhythms found everywhere in nature. The pulsing of crickets in the night, the slow flare of variable stars. You might sense that your mind, once quieted, is as vast as space itself, with thoughts appearing like distant twinkling stars in the expanse of your awareness. This state of calm, serene reflection, where inner space and outer space seem to touch, is a precious experience. Many seekers of truth, philosophers, monks, poets, and scientists alike, have spent nights under the sky yearning for that sensation. Some have described feeling dissolved into the stars, where the boundary of self falls away, and only unity with all things remains. Others have found in the cosmic view a perspective that heals, an understanding that our personal troubles and worries, however heavy, exist within a much larger tapestry of existence. It's not that our lives are unimportant, but realizing that we are part of something vast and enduring can make those burdens easier to bear. It is as if the stars quietly say, "You are not alone. You are part of this great story." Even the silence out here feels alive with meaning. Drifting in the cosmic ocean of night, one can sense the echoes of ancient explosions, the glow of faraway suns, and the soft presence of unseen matter that gently sways galaxies. We know through science that space is not truly empty. It's filled with invisible fields and particles popping in and out of existence. But even without knowing those details, one can feel that emptiness is full of possibility. In a way, the darkness between stars is like the silence between notes of a lullaby, integral to the music, giving it depth and resonance. The quiet of the cosmos is the canvas on which all celestial light is painted. In this serene hush, a question naturally arises. What does it all mean that we are here, able to witness this grand tableau? It's a question both deeply personal and profoundly universal. Perhaps the meaning is simply to witness it, to marvel, to learn, to feel. Perhaps it is to connect, each conscious being a bridge between the stars, sharing in the universe's self-discovery. Or maybe meaning is a human construct, something we create to comfort ourselves in the face of infinity. And yet, even if that is so, there is real comfort. When you stand beneath the sky and feel awe and reverence, that feeling needs no further justification. In that moment, nothing more is needed. You and the universe are in silent conversation, and that is enough. Our awareness, as small as it seems, becomes a precious vessel carrying the universe's memory. In our minds, we hold the history of the stars, the chronicle of how a universe coalesced into galaxies, and how on at least one world, life emerged to see the stars and wonder. That narrative lives on as long as we remember and share it. In a way, the cosmos ensures its own story continues by instilling curiosity in us. Every time you feel compelled to look up and ask why, it is the cosmos nudging you to remember where you came from. Each of us is a storyteller on behalf of the universe, whether we speak through science or art or simple silent wonder. And so, as this reflection on cosmic consciousness flows gently onward, consider how extraordinary it truly is. For a few brief moments in cosmic time, the matter in these hills and oceans coalesced into beings who can feel love and wonder. For a brief era, there are eyes open to see the night, ears to hear the wind in the trees, minds to ponder existence. It may not happen everywhere or often in the universe, or perhaps it happens all the time. We do not yet know. But here and now, it is happening through us. By simply being aware, we fulfill something fundamental about the universe. We give it eyes and ears, thoughts and emotions. Out in the dark sea of space, our planet glows a delicate blue, alive with this awareness. If one could drift high above, one might see Earth as a small lantern of life, flickering with the collective light of billions of souls. Each soul is like a candle, and taken together they make a radiant glow that would be visible if you were near enough. In that metaphor, humanity and all life on Earth are the cosmos gathered into a brief, bright island of knowing and feeling. And though each individual candle may eventually dim, others will ignite in their place, continuing the luminous chorus. The light of consciousness, once lit, has a way of spreading, just as one flame ignites another. It is calming to realize that we belong to this continuum. The cosmic perspective doesn't make us insignificant. It makes us invaluable participants in a cosmic unfolding. We may be tiny, but like a neuron in a vast brain, we have our role in the grand awareness. And collectively, perhaps all conscious beings across the universe, if there are others, form a kind of network of awareness spanning the galaxies. Even if we never meet them, even if the distances remain unbridged, just knowing they could exist expands our sense of family. Under the same stars, in a different sky, others might wonder and hope, just as we do. The universe might be quietly full of such secret sparks of knowing. However, even if we are alone in our galaxy in this moment, that does not diminish the miracle of being here. In fact, it places a gentle responsibility on us to keep the flame of awareness alive, to explore and to cherish, to keep telling the universe's story so it won't be lost in silence. Each lullaby about the stars that we whisper to a child, each question we ask about the cosmos, each dream we have of distant worlds, is part of that responsibility. It is how we honor the gift of consciousness that the universe has, through countless trials and wonders, given to us. It is as if the universe has been holding up a mirror, and in it we see not only the cosmos, but also ourselves. And perhaps that mirror works both ways. When we peer into ourselves, we catch a glimpse of the cosmos. In recognizing this unity, we find a kind of comfort, a sense that we belong here, that we are a natural part of the grand design, as fundamental as a moon orbiting a planet or a thought orbiting the mind. Now, gently bring your attention to your body, allowing the tranquility of your mind to wash over every part of you. Notice how you are supported by your bed or the ground beneath you, by the earth itself. The planet's gravity is like a caring hand holding you safely in place. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and soles soften, and your ankles loosen. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again, and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax, and keep your chest open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and soften. Your face relaxes, and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. Finally, as you prepare to slip into the gentle refuge of sleep, release any remaining worries or thoughts. There is nothing you need to do now, and nowhere you need to be, except here, in this peaceful moment. You are cradled by the cosmos itself, as you have always been. From the moment you were born, every atom in you has been kept in the delicate balance of forces that govern the cosmos. Gravity holds you to Earth and keeps the Earth circling the Sun. Electromagnetic forces bind your atoms together and also generate the light by which we see the stars. Nuclear forces lit the ancient stars that made the elements that became you. The universe has collaborated for billions of years to bring you here now. In a very real sense, you are the universe, in one of its many creative and conscious forms, saying hello to itself, feeling wonder at itself. So, rest now in this knowledge. The cosmos stretches far beyond, full of mysteries and marvels, and it also curls up inside your very being. The journey of discovery is endless, but there's no rush. We have eternity, in a sense, each of us playing our part for a time. As our spoken journey ends, the real journey goes on in every moment, awake or asleep. We close our eyes now on the outward scene, but the inner universe will light up with its stars in dreams. May your dreams be gentle and filled with the quiet grandeur of the cosmos. And when you wake, may you carry a bit of this starlit peace into your day, remembering that beyond the hustle of life, the cosmos and your soul move together in an ancient and endless dance. Good night and sweet dreams under the eternal sky above.